Hey guys, welcome to this session by Intellipaat. So we live in an era where data is our most important asset and it is being used at the heart of every decision making process. And that's why it becomes very important for us to learn SQL so that we can mine data very easily and also with greater efficiency. So keeping this in mind, we have come up with an end-to-end SQL developer course so that you can learn all the major concepts of SQL. And before we go ahead and start a session, do subscribe to our channel and like and share our video so that we can create more such informative content. Right, so let's have a quick glance at the agenda. We'll start off by understanding what exactly is a database and learn how to create and use a database. After that, we'll learn how to create a table and then learn how to extract data from it with various clauses and operators. Going ahead, we'll learn how to join different tables using different join statements, following which we'll work with different inbuilt functions and user-defined functions. After that, we'll work with stored procedures and transactions in SQL, and finally, we'll learn how to implement exception handling.
So what exactly is a database? Well, simply put, it's just an organized collection of data that is stored in an electronic format. More specifically, a database is an electronic system that allows us to easily access, manipulate, and update the data. Now, the modern databases are managed using something known as a database management system. So, a database management system or DBMS is basically a system software for creating and managing databases. So, the DBMS provides users and programmers with a systematic way to create, retrieve, update, and manage data. So now that we've understood what exactly is a database and database management system, let's have a look at the types of database architecture. So the database architecture could either be file server or client server. So let's start with the file server architecture. So in the file server architecture, the files are located on your local system. That is, they are local to you. Now, suppose you have an Excel file with you and you send a copy to your friend. Now, if you make any changes in your original Excel file, those changes would not be reflected in the file with your friend. So, in the file server architecture, the server or the local system acts only as a storage device and only one person at a time can access it. So, this is the basic premise behind file server architecture. Now, let's look at client server architecture. So we can see that there are three OLEDB components, or in other words, they are just client systems or the user systems. So we have just shown three over here, but there can actually be n number of systems accessing the database at the same time. So let's say you're logged into the IRCTC website and want to know the number of trains running from one place to another place. So you'll send a request from this system to the network server. Now this network server sends the same request to the database server and this is finally forwarded to the database. And then the final result is sent back to the user system. So similarly, if there are three users sending the same request, the database server will process all the three requests simultaneously and send back the result to all the three systems. So that was about the types of database architecture. Now let's finally understand what exactly is SQL. So SQL basically stands for Structured Query Language, and it is the standard language for accessing and manipulating databases. Or in simple terms, SQL helps you to communicate with a database. Now the SQL commands can be divided into four categories: data query language, data definition language, data manipulation language, and data control language. So the data query language comprises of just one command, select, though it can be accompanied with many clauses to compose queries against a database. And DDL is that part of SQL that allows a user to create and restructure database objects. So you can see commands like create table, alt table, and drop table in DDL. After that, we have data manipulation language, which is used to manipulate the data within tables. So the three basic DML commands are insert, update, and delete. And finally, we have data control commands, which allow us to control access to data within the database. So these DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. And you can see commands like grant and revoke in DCL. We'll be installing Microsoft SQL Server. So all you have to do is go to Google and then type Microsoft SQL Server download, and you'll get these search results. Now, out of these search results, click this one where you see SQL Server downloads from the Microsoft site. So we are into the site now. If I scroll down, we see two free editions. We have the Developer Edition and the Express Edition. So I'd be downloading the Developer Edition. I'll click on download and the download would start. Now this is the downloaded file over here. SQL Server 2017 SSEI development. So we get this window over here and we have three options: basic, custom and download media. So I'll click on custom. Now we see that we have a media location where the SQL Server will be downloaded, and I'll click on install. So see that the download is successful and our installation will begin shortly. Here I'll click on installation and I'll select this one. So I'll be installing a standalone installation of the SQL Server. So let us wait for this to open. Right, so here I click on next. Now I already have one instance of SQL Server, so I'll be installing a new one. So I'll select this perform a new installation of SQL Server 2017. And then I'll select this free edition. I'll click on next. After that, I'll accept this license agreement and again I'll click on next. So we have all of these features over here. So I would just need the database engine services. So I'll select this and again I'll click on next. So I'd have to name the instance for the server which I'm installing. So I'll name this server as, let's say, Sparta. Similarly, I'll give the same instance ID over here. I'll click on next. So again, I'll click on next over here. So we see that we have two authentication modes: Windows authentication mode and mixed mode. I'll select the mixed mode and then enter the desired password. Let me put in my password over here. I'll add the current user. So the current user has been added. Now I'll click on next again. Right, so we are finally ready to install SQL Server. I'll click on install. Right, so once the installation is done, I would also have to install the SQL Server management tools. So these SQL Server management tools basically help us to connect with the database. I'll click on this. And this will redirect us to the Microsoft web page. And over here, I'd have to download the SQL Server Management Studio, and I'll be downloading the latest version. And this is the downloaded file over here, SSMS setup ENU. I'll click on this. So over here we have these three options: repair, uninstall and close. Now I have these three options because I've already installed Microsoft SQL Server Management Studio in my system. And if you're installing this for the first time, you'll have the install button over here. So you'd have to click on install and the install would be done automatically. Right, so once you install the SQL Server Management tools, go to the search tool and type Microsoft SQL Server Management Studio. Click on this. And Microsoft SQL Server Management Studio will start. So over here you would have to specify the password which you gave while creating the instance. And then click on connect. And to start writing your SQL commands, click on new query over here. And then you can happily implement all of your SQL commands. Right, so this was the installation of Microsoft SQL Server. Tables in SQL. So simply put, a table is a database object which comprises of rows and columns. And in SQL, the rows are known as records and the columns are known as fields. So the fields are basically columns which provide specific information about data in the table. For example, we have this e-salary field in the table which provides information about the salary of different employees. Similarly, we have this e-age field which provides information about the age of different employees. And a record is basically each individual entry that exists in the table. So record gives you complete information of one single entity. For example, if we take this record over here, this would give us complete information of this particular employee. So this was all about tables. How to create, use and drop a database. So this is the syntax to create a database in SQL. We will give in the keywords create database and then give the name of the database which you want to create. So let's go ahead and create a database in SQL. So let's create a first database, guys. So I will give in the keywords create database and let's say I want to name the database as happy, right? So I'll put a semicolon over here. I'll hit execute. So see that commands have been completed successfully. Now let me hit refresh over here. So initially we just had two databases, Igneous and Sparta. After implementing this command create database happy, we have successfully created a new database happy. Now after we have created a database, we need to know how to select a database from our existing list of databases. So we have the use database statement for this. All we have to do is give the keyword use and then state the name of the database. Now this database which you selected remains default until the end of a session or execution of another use statement with some other database. So if I put my mouse pointer over here, so we see that currently we are using the Sparta database. So now I want to use the happy database instead of the Sparta database. So I will write the command for that use and then after that I need to give in the database which would be happy. I'll put a semicolon, I'll hit execute. So again, commands have been completed successfully. So now we see that the database has changed from Sparta to happy. So currently we are inside the happy database. Now we'll see how to delete a database, or in other words, how to drop a database. So we have to give in the keywords drop database and then specify the name of the database which you want to drop. So now I want to drop this Igneous database. So let me write the command for that. Drop database and then the name of the database is Igneous. So I'll put a semicolon over here. I'll hit execute. So again, commands have been completed successfully. Now I'll hit refresh. So we have only two databases, Happy and Sparta. So the database Igneous has been dropped. Data types in SQL. So a data type basically defines the kind of data that will go into a particular column. Now it needs to be kept in mind that all the entries of one particular column would have the same data type. So let's take this e-salary column for example. We see that the first entry is of integer type. The second entry is also of integer type. Similarly, all the entries of this e-salary column are of integer type. Now let's take this department column. Here we see that all the entries of this particular column are of character type. Now that we've understood what exactly are data types, let's have a look at the different data types available in SQL. Let's start with the numerical data types. So we have the big int data type which helps us to store really big values. So you can see the range of big int over here. Then we have the int data type which helps us to store reasonably big values. After that we have the small int data type and the range of small int is from minus 32,768 to 32,767. Then there's tiny int and the range is only between 0 to 255. After that we have the decimal data type and it is used to store fractional values. So the decimal data type takes in two arguments. First is the size of the value, that is the total number of digits. Then we need to specify the number of digits after the decimal point. Let's say we want to store the decimal value 12.50. Here the size would be 4 because the total number of digits are 4 and value of d would be 2 because there are 2 digits after the decimal point. Now let's have a look at the character data types. So first we have the char data type. This takes in one argument which is the size of the value. Let's say you set the size to be 20. This would mean you cannot give in a value which would have more than 20 characters. Now you need to keep in mind that char is a fixed length data type. That is, if you set the size to be 30 but you given only 3 characters, then the memory which would be consumed is of 30 characters. So you are basically wasting the memory over here. Then we have the varchar data type. This again takes in size as the argument. Now varchar is a variable length data type unlike char. So here if you set the size to be 30 and given only 3 characters, the memory consumed would be only 3. Then we have the text data type. So this data type can take in a string with a maximum length of 65,535 characters. Then we have the date and time data types. Well, start with the date data type. So this data type helps us to specify the date in this format over here. Let's say we want to store the date 2nd January 2019. Then first we will give in the year, which would be 2019. Then we'll specify the month, which would be 01. And finally we'll specify the day, which is 02. After that we have the time data type, and this helps us to specify the time represented in the format over here. Now let's say I want to store the time 8:30 a.m. 23 seconds. So first I'll specify the hour, which would be 08. Then I'll specify the minutes, which is 30. And finally specify the seconds, which would be 23. Then we have the year data type, which just holds the year values such as 1995 or 2011. So constraints are basically used to specify some rules on the data and limit the type of data that can go into a table. We will look at these 4 constraints: not null, default, unique, and primary key. Let's start with the not null constraint. So by default, a column can hold null values. And with the help of the not null constraint, we can ensure that a column does not have null values. So the not null constraint basically ensures that a field always contains a value. For example, if we assign the not null constraint to this eSalary column over here, then every single entry of this column should have a value. Then we have the default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to the EH column and set a default value of 25, then all the entries of this column will have the default value of 25 if no other value is specified during insertion. Then we have the unique constraint, which ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry of this column should have a unique value. And finally, we have the primary key constraint. So the primary key constraint uniquely identifies each record in a table. Or simply put, it is just a combination of the not null constraint and the unique constraint. So when we assign the primary key constraint to a column, then that column shouldn't have any null values and all the entries should also be unique. For example, if we assign the primary key constraint to the employee ID column, then there should be no null values in this column and all the entries should also be unique. How to create a table in SQL? So we'll be creating an employee table which would comprise of employee ID, employee name, the employee's salary, age and gender, and the department in which the employee works. So let's have a look at the steps to create a table in SQL. So first we'd have to start off by giving a name to the table. After naming the table, we'd have to define the columns which would be a part of our table. And finally, we'd have to assign a data type to each of the column which we have defined. Now let's have a look at the create table syntax. So first we'd have to specify the 2 keywords which are create table, and then we'll give a space and then give a name to the table. And inside the parenthesis, we will define all of our columns and assign them their respective data types. Now finally, if you want to give a primary key constraint, we can do it over here. So we will give in the keywords primary key and then give in the name of the column which would be a primary key. So as we have already learned in a previous session, a primary key basically helps us to uniquely identify all of the records in our table. And guys, also keep this in mind. A table cannot have more than one primary key. So now that we've understood the syntax of create table command, let's go to MS SQL Server and create our employee table. Right, so this is MS SQL Server. So I'll start with the command. I will give in the keywords create table. Then I will give in the name of the table, which would be employee. And inside the parenthesis, I will give all of the columns. So the first column would be employee ID. So I will type EID, which is the name of the first column, and this is of type integer. Now after this, I will also put in the not null constraint. So this not null constraint means that all of the cells in this column should definitely have a value. And then I will give in the second column. So the second column is employee name. So E name, and this is of type varchar. So varchar stands for variable length character. and the maximum length would be 20. Then I'll give in the third column. So the third column would be employee salary. So I will name the column to be E salary, and this would be of type integer again. After this, we have the employee's age. So the column name would be EH, and this is of type integer too. Then we have the employee's gender. So I will name the column to be E gender, and this would be of type var_char. So this is of variable length character, and the maximum length is 20. And then we will give in the final column. So the final column would be the department in which the employee works. So let me name it to be EDEPT, and this would be of type varchar2 and a maximum length of 20. Now after this, I can set in the primary key. So I want this employee ID column to be the primary key. I will type primary key, and inside the parenthesis, I will give in EID. Right. Now I will put in semicolon over here to indicate that this is the end of the syntax. Now I will select all of this and click on execute. Right. So we have successfully created the employee table. How to insert records into a table? We can insert records with this insert into statement. Now let's understand this command properly. So first we'd have to type in the keywords insert into, then we'll give in the table name, following which we'll give in the keyword values. And inside the parenthesis, we'd have to give in the values for each of the column respectively. Now let's go to MS SQL Server and insert records into our employee table. So let me start with the command. So I will type in insert into, then I'd have to give in the name of the table, which would be employee, after which I will give in the keyword values. And inside the parenthesis, I can give in all of the records. So let me start with the first record. Right. So we'll have to start off with the employee ID. So the employee ID is, let's say, 1. Then the second column is the employee's name. And this is of type varchar. That is why I will give in the value inside these single quotes. So the employee's name is Sam. After this, we would have to give in the employee's salary. So Sam earns $95,000 per annum. I will give in 95,000 over here. Then we have the employee's age. So Sam's age is 45. After which we have the employee's gender. Again, since this is a variable character, so I will use the single quotes over here, and Sam is male, obviously. After which we'd have to give in the department in which the employee works. So again, this is variable length character. I will give in single quotes, and Sam works in operations. So let me type in operations over here. Right. Now I will put in semicolon over here. I will select all of this and I will click on execute. So we have successfully inserted one record into our table. Now let me follow the same procedure and insert another record. So insert into employee values, and inside the parenthesis, the first column is employee ID, which would be 2. After this, I'd have to give in the name of the employee. So the name of the employee is Bob, and Bob earns $80,000, which is his salary. So let me put in 80,000 over here. Then we have the employee's age. So Bob's age is 21. Then we have the gender of the employee. So Bob is male, obviously again. Then we'd have to give in the department in which the employee works. So Bob works in support. Again, I will put in semicolon. I'd have to select all of these. Let me click on execute. Right, so we have also inserted the second record. Now let me insert the third record. So again, it would be the same command. Insert into employee values. Inside the brackets, let me give all of the values for the columns. So employee ID is 3. The name is Anne. And Anne's salary is $125,000 per annum. She's quite rich, isn't she? And her age is 25. And she's obviously female. Now we'd have to give in the department in which the employee works. So Anne works in analytics. Let me type in analytics over here. So it seems like people who work in analytics earn quite a lot, doesn't it? So let me put in semicolon over here. I'll select all of these and let me click execute. So similarly, I will insert 3 more records into the same table. Right, so we have successfully inserted 6 records into a table. So guys, this is how we can insert records into a table. How to select data from our table? So first we will work with the select statement and learn how to extract individual columns. Then we will work with the select distinct statement to select only distinct values. So the select query is one of the most important commands in SQL, and it is used to get data from our table. So let's have a look at the syntax. So first we'd give the keyword select and then list down all of the column names that we want to select. Following which we'll give the keyword from and then finally give the table name from which we are supposed to select these columns. So let's select some data from our employee table. So let's say I want to extract only the employee name column from the employee table. So for that, I would have to give in select and then I would have to give in the name of the column. So the name of the column is ename and then I will give in the from keyword, after which I will give in the name of the table, which is employee. So let me put in semicolon and let me hit execute. Right, so I have successfully extracted only the name column from the entire employee table. So similarly, if I wanted to extract only the age column from the employee table, we would have to put in a similar syntax. So it would be select employee age from and the name of the table is employee. Execute. Right, so we have extracted the age column from the entire employee table. Now we can also extract multiple columns from our table. So for that, we'd have to separate each of the columns with a comma. So let's say I'd want to extract the name column, the gender column, and the salary column from the entire employee table. So let me write the syntax for that. So it would be select. So I will give in the first column, which would be ename. Now I would also want the gender. So I will put in egender. I'll put in a comma. And then I would also want the salary column. So I will put in salary. After which I will use the from keyword and then I will give in the name of the table, which would be employee semicolon and let me hit execute. Right, so I have extracted 3 columns from the employee table and those 3 columns are ename, egender and esalary. So this is how we can extract multiple columns from the same table. Now we can also extract the entire data from our table. And to extract the entire data from our table, we'd have to use the asterisk operator. So let me show you guys how it's done. So the command would be select and then I will put in star, after which it will be from employee. So as simple as that, guys. Select star from employee. So whatever table it is, all you have to do is select star from and then you'd have to give in the table name. So this is how you can extract all of the data from a particular table. So I will give in semicolon and let me hit execute. Right. So when I gave the command select star from employee, I was able to extract all of the data from the employee table. Now let's look at the select distinct statement. So a column often contains many duplicate values. And sometimes we'd want to extract only the distinct values from the column. So this is where select distinct comes in. So the syntax of select and select distinct is pretty much the same. The only difference is we follow up the select keyword with the distinct keyword. Now let's select some distinct values from our employee table. If we have a glance at this gender column, we see that these 2 values are being repeated. So we just have 2 values, male and female, and these 2 values are being repeated. So now if I wanted to extract only the distinct values, so this would be the command for that. So I will type in select and I'll follow up the select keyword with the distinct keyword. After which I'll give in the column name whose distinct values I'd want. So the column name would be egender and then it'll be from the name of the table, which is employee. So let's see what do we get. Select distinct egender from employee. Right, so we see that we only get the distinct values which are female and male. Now let me actually remove this distinct keyword and let me hit execute. So let's see what is the difference. Right, so if I remove the distinct keyword, we get all of the values. So male, male, female, female, male and female. Now, so if we use the distinct keyword, we'll only get the values which are different. So these are the cases where select distinct can be used. So the where clause is used to extract only those records that fulfill a specified condition. For example, we'd want to extract those records where the age of the person is more than 60. Or filter out those records where the occupation of the person is doctor. Now let's have a look at the syntax of where clause. So we'll start with the select keyword. Then we will give in the list of all of the columns which we want to select. Following which we'll use the from keyword and give the table name. And finally use the where keyword and follow it up with a condition that would determine which records are to be extracted. So let's filter out some records from our employee table. Now let's say we'd want to find out all of the female employees of our company. So for this, I'd have to extract those records where the gender equals female. So let me go ahead and write the command for that. So that would be select star from, I will give in the table name, which is employee, and then I will use the where keyword and follow it up with the condition. So the condition would be E gender is equal to female. Right, so what I'm basically doing is I am extracting all of the female employees from this employee table. Let me hit execute. Right, so Anne and Julia are the only female employees. Now I'd want to find out those employees whose age is less than 30. So let me write the command for that. Select star from employee where I will give in the condition. So this time the condition would be E age is less than 30, right? So the age needs to be less than 30. I'll give a semicolon. Let me hit execute, right? So these are the three employees, or these are the three records where the value of E age is less than 30. So Bob, Anne and Jeff, these are the three employees whose age is less than 30. Now similarly, let's say I want to find out all of those employees whose salary is greater than $100,000. So let me write the command for that. So this time the command would be select star from employee where, so the condition would be E salary is greater than 100,000, semicolon, and execute. So Anne, Matt and Jeff are the three employees whose salary is greater than $100,000. So Anne's salary is $125,000, Matt's salary is $159,000 and Jeff's salary is $112,000. So guys, this is how we can filter out records with the where clause. How to extract records on the basis of multiple conditions using the AND, OR and NOT operators. So we'll start with the AND operator first, then we'll filter records with the OR operator, and finally we'll work with the NOT operator. So with the AND operator, we can basically fetch those records which satisfy all of the conditions separated by AND. For example, we want to find out all the doctors whose age is greater than 60. So there are two conditions over here. First, the age needs to be greater than 60. Second, the occupation needs to be doctor. So we'll get only those records where both the conditions are being satisfied. Now let's have a look at the syntax. So here, after we give the first condition of the where clause, we follow it up with the AND operator and give the second condition. And similarly, if we have another condition to be satisfied, we'll again give the AND operator and then give the next condition. So let's fetch some records using the AND operator. So I'd want to extract all of those employees whose gender is male and age is less than 30. So the command would be select star from employee. I'll use the where clause and then given the first condition. So the first condition is gender needs to be equal to male. So E gender is equal to male. I'll use the AND operator and then given the second condition. So the second condition is the age needs to be less than 30. Let me hit execute. Right, so Bob and Jeff are the two employees whose gender is male and age is less than 30. Now similarly, I'd want to extract all of those employees who work in the operations department and their salary is greater than $100,000. So the command would be select star from employee where I have to give the first condition. So the first condition is the department needs to be equal to operations. I'll use the AND operator again. And then I'll give the second condition. So the second condition is the salary needs to be greater than $100,000. Right. Execute. So Jeff is the only employee who works in operations and his salary is greater than $100,000. Then we have the OR operator. So the OR operator displays those records where at least one of the conditions is satisfied. For example, if we want to filter out either a software engineer or a doctor, then we can use the OR operator. And this is the syntax for the OR operator. So similar to AND operator, after we give the first condition, We follow it up with the OR operator and then give the second condition. Now we'll fetch some records from the employee table using the OR operator. So I want to extract all of those records where the employee works either in operations or in analytics. So the command would be select star from employee where we need to get the first condition. So the first condition is department should be equal to operations. I'll use the OR operator now and then give the second condition. So the second condition is the department needs to be equal to analytics. Right. So we have 4 records over here. So Sam works in operations, Anne works in analytics, Julia works in analytics, and Jeff works in operations. So there are 4 results, out of which 2 people work in operations and 2 people work in analytics. Now similarly, I'd want to extract those records where either the salary is greater than $100,000 or the age is greater than 30. So this would be the command select star from employee where salary is greater than $100,000. I'd have to use the OR operator and then give the second condition. So the second condition is age needs to be greater than 30. Execute. So again we have 4 records over here. So the first record is Sam, whose age is greater than 45. Then we have Anne, whose salary is greater than $100,000. Then we have Matt, which satisfy both the conditions actually. His salary is greater than $100,000 and his age is also greater than 30. Then we have Jeff, whose salary is greater than $100,000. So these 4 records, we see that at least one of these conditions is being satisfied. And finally we have the NOT operator. So with the NOT operator, we can extract those records where the condition is not true. For example, if I wanted to extract all those records where the occupation of the person is not equal to software engineer, then I'll use the NOT operator. So let's have a look at the syntax of NOT operator. So here we follow up the where clause with the NOT operator and then give the condition. Now let's work with this NOT operator. So I want to extract all of those records where the gender is not equal to female. So the command would be select star from employee where after where clause I need to use the NOT operator and then give the condition. So gender is equal to female, right? So before the condition I use the NOT operator. So this would basically give me all of the records where gender is not equal to female. So I'll hit execute. So see that I get 4 records in total and all of those 4 records the gender value is male. Now similarly I'll extract all of those records where the age is not less than 30. Right? So select star from employee where I need to follow it up with the NOT operator and then give the condition which would be E of age is less than 30. So this is the actual condition, E of age is less than 30, and since I preceded with the NOT operator, I will get all of the records where age is actually not less than 30. I'll hit execute. So these are the 3 employees whose age is not less than 30. We have Sam, whose age is 45, we have Julia, whose age is exactly 30, and then we have Matt, whose age is 33. So guys, this is how we can work with AND, OR and NOT operators. How to extract records with the like and between operators. We'll start with the like operator. So the like operator is used to extract those records from a table where a particular pattern is present. For example, we'd want to extract all those records where the person's name includes John. So if we have records of 3 people in our table with the names Jonathan, Johnny and Marcus, then with the help of like operator, we can extract records where the names are Jonathan and Johnny, since they have the required pattern present in them. Now, the like operator is used in conjunction with the wildcard characters. And there are 2 wildcard characters. First one is the percentage symbol and the second one is the underscore character. So the percentage symbol is substitution for 0, 1 or more characters, while the percentage symbol is substitution for a single character. And this is the syntax for the like operator. After giving the where clause, we given the column name followed by the like operator and then the pattern which you want to extract. And keep this in mind, guys, the pattern should be inside single quotes. Now let's do some operations with the like operator. So let's say I want to extract all of those records where the employee's name starts with the letter J. So the command would be select star from employee where I will give in the condition which would be name, following which I will give in the like operator and inside single quotes, since the name should start with J, I will type J, after which I will use the percentage wildcard. So all of those names which start with J would be extracted with this command. So let me hit execute. So Julia and Jeff are the two employees whose name starts with J. Now similarly, I'd want to extract all of those employees whose age is in the 30s, right? Select star from employee where I need to give the condition. So age, following which I'll give the like operator and then inside single quotes the age needs to be in 30s. So after 3 I will use the underscore wildcard character and then put in the semicolon. Let me hit execute. So we have Julia and Matt over here. So Julia's age is 30 and Matt's age is 33. So they are the two employees whose age is in the 30s. Now let's look at the between operator. So the between operator is used to select values between a given range. For example, we can extract only those records where the age of the person is between 20 and 25. And this is the syntax. After where clause, we give in the name of the column, then we give the between keyword, after which we give in the lower value of the range, then use the AND operator, and then give the maximum value of the range. So I want to extract all of those employees whose age is between 25 and 35. So the command would be select star from employee where the condition would be age should be between 25 and 35. Execute. So Anne, Julia, Matt and Jeff are the 4 employees whose age is between 25 and 35. So as you see over here, this value is inclusive, right? 25 is inclusive. So Anne's age is 25, Julia's age is 30, Matt's age is 33 and Jeff's age is 27. And these are the 4 employees whose age is between 25 and 35. Now similarly, I'd want to extract all of those employees whose salary is between $90,000 and $120,000. So the command would be select star from, I need to give in the name of the table which is employee. Then I'll use the where clause and then give the condition. So the condition would be salary between, so the salary needs to be between $90,000 and $120,000. I'll press semicolon. Let me hit execute. So Sam and Jeff are the 2 employees whose salary is between $90,000 and $120,000. So Sam's salary is $95,000 and Jeff's salary is $112,000. Some basic functions in SQL. So we'll look at the min function, max function, count function, sum function and average function. Let's start with the min function. The min function gives the smallest value in a column. Let's look at the syntax. First we give in the select keyword, then we give the min function and inside the parenthesis we specify the name of that column from which we are supposed to find the minimum value. So I want to extract the age of the youngest employee of the company. So this would be the command for that. Select and then I'll use the min function and then pass in the column which would be age. I'll use the from keyword and then give in the name of the table which would be employee. So the total command is select minimum of age from employee. I'll hit execute. So we see that the minimum age in the table is 21. Similarly, if I wanted to extract the salary of that employee who would get the least salary, so the command would be select min and instead of age it would be salary from employee. So the salary of the employee who earns the least is $73,000. Then we have the max function. The max function gives the largest value in a column. Here again we give in the select keyword, following which we give the max function and inside the function we specify the name of the column from which we're supposed to get the maximum value. Now I want to extract the maximum age and maximum salary from this table. So this would be the command for that. Select, and I will start off by extracting the maximum age. Inside the max function, I will pass in the column which is E of age, and then I'll use the from keyword and then given the name of the table which is employee. So the maximum age of an employee is 45. Similarly, I want to find out the maximum salary. So that would be E salary from employee. Execute. So the maximum salary is $159,000. Then there's a count function. So the count function returns the number of rows that match a specified criteria. That is, if we wanted to find out the number of male and female employees in a company, then we can use the count function. Let's look at the syntax. So after the select keyword, you will use the count function and given an asterisk inside the parenthesis. Then you will give the table name, and finally you will use the where clause to give the condition. So let's use this count function to get the count of number of male and female employees. So I'll start off by getting the count of number of male employees. So select, I will use the count function, and inside the count function I will pass in the asterisk symbol. After which I'll use the from keyword and then given the name of the table which would be employee. Then using the where clause I will give in the condition. So I'd want the count of all of the male employees. So E of gender should be equal to male. Let me see what do we get. So there are 4 male employees in total. Similarly, if I wanted to get the count of all the female employees, the command would be select count of star from employee where E gender equals female. Right, so this would be the only difference. I'll hit execute. So I get 2. So there are 2 female employees in the entire organization. Then we have the sum function. So the sum function would give you the total sum of a numeric column, and this is the syntax. So here similarly, we will give in the sum function after the select keyword and give the column name inside the parenthesis. So I want to get the total sum of salaries of all of the employees, right? So the sum of salaries of all of the employees. Select, and then I'll use the sum function, and then I'll pass in the column which would be E salary from the name of the table which is employee. So the total salary of all of the employees included is $644,000 per annum. And finally we have the average function. So the average function gives us the average value of a numeric column. And the syntax is same as the rest. So we'll give in the average function after the select keyword and give the column name inside the parenthesis. So this time I want to get the average age of all of the employees. So select, and then I will use the avg function and then given the column which would be age from the name of the table which is employee. So the average age of all of the employees is 30. So guys, these were some of the aggregate functions in SQL. Some string functions. So first we have the ltrim function, which helps in removing the blank spaces on the left side of the character expression. So let's implement this function in SQL Server. So let me first create a string with some blank spaces on the left side. So I'll type select, and then I will give some blank spaces on the left side. Now let me pass in a string, and I'll name the string to be Sparta. I'll hit execute. Right. So this is the string which has some leading spaces on the left side. Now if I want to remove all of these blank spaces on the left side, all I need to do is use the ltrim function. So I will type select ltrim, and inside this I will pass in the string with the leading spaces. So I'll copy this and I will paste it over here. Now let me execute both of this simultaneously. Right? So this is the string with the leading spaces, and when we use the ltrim function, all of those blank spaces on the left side were removed. Then we have the lower function, which basically converts all the characters to the lower case. So let's look at an example. This time, let me actually print a string which has all the characters in capitals. So this is Sparta. So here we see that all of the characters in the string are in capitals. I'll execute this, and this is what we get. Now if I want to convert all of the characters into lowercase, I can just use a lower function. So I will type select lower and then pass in the string inside the function. I'll copy the string. I will paste it inside this. I'll hit execute. So this is the string where all the characters were in capitals, and after using the lower function, this string where all the characters were in capitals have been turned to lowercase. Similarly, we have the upper function, which basically converts all the characters to uppercase. So this time I will take in a string which has all the characters in lowercase. So select, I will type hello world. Let me print this, right? So here we see that initially all of the characters are in lowercase. Now after this, I will type select upper and then pass in the string inside the function. I'll copy this. I will paste it over here. I'll hit execute. So this was our initial string, and after using the upper function, we have converted the string into capital case. After that, we have the reverse function, which basically reverses all the characters in the string. So let's implement this too. So let me take in a random string again. Select, and I will type I love ice cream. I'll hit execute. So this is what we get initially. Now after this, I will use the reverse function. Select, reverse, and I will pass in the string inside the reverse function. I'll copy it and I will paste it inside this function over here. Now let me execute. So this is the initial string, and after using the reverse function, we have reversed all of the characters in the string, right? So you see that this is the starting and this is the ending over here, and after reversing it, we get this final string. And finally, we have the substring function, which gives us a substring or part of the string from the original string. Now let me give in the original string first. So I will type select, and then the string would be this is Sparta. Now let's say I would want this substring Sparta from this entire string. So this is where we can use the substring function. So I will type select substring. Now the substring function takes in three parameters. First is the original string. So I will copy the original string and I will pass it into this as the first parameter. Now after that, I need to give in the index value from where the substring starts. So this is the first character of the substring which I want. So the index value would be 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I'll type 9 over here. And then the third parameter would be the length of the substring. So the length of the substring is 1, 2, 3, 4, 5 and 6. So I will pass in 6 over here. Now let me execute all of this and let's see what do we get. So this is the original string, this is Pada. And after using the substring function, we have extracted only this part from the entire string. So these were some of the string functions in SQL. Order by and the top clause. So order by is used to sort the data in ascending or descending order. And by default, order by sorts the records in ascending order. So let's have a look at the syntax. We'll start with a select keyword and then given the column list. Then we'll use the from keyword and give the table name. Following which we'll type the keywords order, by, and give the columns with respect to which you want to sort the data. And finally, we'll state whether the ordering should be in ascending or descending. And I've already told you guys that by default, the sorting is done in ascending order. And if you want the sorting to be done in descending order, we will use the DESC keyword. So I want to sort the table with respect to the salary column in ascending order. So this would be the command for that. Select start from, the name of the table is employee, after which I will use the keywords order by and then given the name of the column, which would be salary. And since I want it with respect to ascending order, so I don't need to add anything else. So let me hit execute. Right, so we have successfully sorted this table in ascending order, right? So Julia has the lowest salary and Matt over here has the highest salary. So this is an ascending order, 73,000, 80,000, 95,000 and goes on till 159,000. Now let's say I want to sort this table in descending order of the salary. So for that, all I need to do is add in the keyword DESC. Let me hit execute, right? So this time the table is sorted in descending order, right? So over here at the top, we have the maximum salary, which is 159,000. And at the bottom, we have the lowest salary, which is 73,000. Now let's look at the top clause. The top clause is used to fetch the top n records from a table. So Top class is useful on large tables with thousands of records. And this is the syntax. We've got the select keyword first, then we type in top, and then the number of records we want to see in our result, followed by the column list. And then we use the from keyword and given the name of the table. So I'd want to see only the top 3 records from the entire employee table. So this would be the command for that. Select, and then I will use the top keyword, and since I want 3 records, the number would be 3. And since I want to see all of the columns, I will put in star over here. Then I want all of these records from the employee table. So this is the entire command. Select top 3 star from employee. I'll hit execute, right? So I've got the top 3 records from the table. Now I will use the top clause and the order by clause and fetch the 3 oldest employees of this company. So let me write the command for that. Select top 3 star. So I've used the top clause to fetch the top 3 records. Now this would be from the employee table, and then I will use the order by clause. So I want to order it with respect to the age of the employee, and I want it in descending order. That is, the employee who has the maximum age should be at the top. Now let me hit execute. So I've got 3 records over here, and the records are arranged in descending order of their age. So Sam has the highest age 45, and Julia over here has the lowest age 30, right? So Sam, Matt and Julia are the 3 senior most employees of this company. And this is how we can work with the order by clause and the top clause. The group by statement. The group by statement is used to get aggregate result with respect to a group. For example, let's say we wanted to find out the average salary with respect to gender. That is, average salary of male employees separately and average salary of female employees separately. This is where we can use group by to divide the data into 2 groups, male and female, and find out the average salary of each group separately. Now let's have a look at the syntax. So here you'd have to be careful of the sequence. So the group by clause follows the where clause and precedes the order by clause. So if you mix up the sequence, then you may not get the right result. And if you're not using the where clause and the order by clause, you can directly follow up the group by statement after the table name. So I would want the average salary with respect to the gender. So this would be the syntax for that. Select, and since I want the average salary, I will use the avg aggregate function and then given the name of the column, which would be e salary. And since I also want to see the gender column, I will give in e gender over here. And this is from the employee table. And since I have already given the name of the table, I can use the group by statement over here. And after the group by statement, I need to give in the column with respect to which I have to group the data. And I want to group the data with respect to the gender column. So this would be my total command. Select average of e salary and e gender from employee, group by e gender. So let me hit execute, right? So this is the average salary with respect to the female employees, and this is the average salary with respect to the male employees. So the average salary of female employees is around $99,000 per annum, and the average salary of male employees is around $111,000 per annum. Now I want the average age with respect to the department, and I'll also use the order by keyword to sort the data in descending order with respect to the average age. So this is the syntax. Select. Since I want the average age, I will use the average aggregate function and then pass in the column, which would be e age. And I would also want to have a glance at the department. So e dept. I will give in the name of the table, which would be employee. After which I will give in the group by statement, and I want to group this with respect to the department. So group by EDEPT, and after the group by statement I need to give the order by statement. So order by, and I want to order the result with respect to the average age. So again this would be average age, and I want the sorting to be in descending order. So DESC. So this is a total command. Select average, E age and E department. So I'll be getting the average age and the department column from the employee table, and I'm grouping it with respect to the department column, and I'm sorting it in descending order of the age. So this would be E age over here. So let me hit execute. So we have the average age with respect to each department ordered in descending order. So operations department has the maximum average age of 36, then sales has an average age of 33, analytics department has an average age of 27, and support has the youngest staff of age 21. And this is how we can use a group by clause. The having clause is used in conjunction with the group by statement to impose certain conditions on the groups which are to be displayed. So the having clause was added to SQL because the where keyword could not be used with aggregate functions. For example, over here we have four departments A, B, C and D. And we also have the corresponding average salary of the employees belonging to each department. Now let's say we wanted to see only those departments where the average salary is greater than $100,000. So this is where having clause can be used to impose the condition and get only those departments where the average salary is greater than $100,000. And this is the syntax for the having clause. Here you need to keep in mind that the having clause must follow the group by clause and must also precede the order by clause if used. So let's go to SQL Server and implement the having clause. So we'll group this table with respect to the department column and then use the having clause to display only those departments where the average salary is greater than $100,000. So let me go ahead and write the syntax for that. I will type in the select keyword and then list down all of the columns which I want from this employee table. So I need the department column. I would also need the average salary. So I'll use the aggregate function avg and then pass in the column which is eSalary. And I will name this column as average salary. Now I would want this from the employee table. So I'll use the from keyword and then give the name of the table which is employee. After this I'll give the group by keyword to group this table with respect to the department column. So I will give in the name of the column which is EDEPT. Now before I go ahead and use the having clause, let me actually execute just these three lines of code. Right. So what I've basically done is I have grouped this employee table with respect to the department column and we have the average salary with respect to each of these departments. Right. So this is the average salary of analytics department, average salary of operations department and average salary of sales and support. Now I will use the having clause to display only those records where the average salary is greater than $100,000. So the average salary needs to be greater than $100,000. Now I'll select all of this, I'll hit execute. Right, so we see that out of the four departments, only operations and sales department have the average salary of the employees to be greater than $100,000. So the average salary of employees in operations department is $103,000 and the average salary in the sales department is $159,000. This is how we can work with the having clause in SQL. So the update statement is used to modify or change the existing records in a table. And this is the syntax for the update statement. So we'll start with the update keyword and then given the name of the table. Then we'll use the set keyword and assign new values to the columns which you want to update. And finally we'll use the where clause to give in the condition which should determine where the columns are to be updated. So I've put in the where clause over here in square brackets because it is optional. Now let's update some records of our employee table. So this is our employee table and I want to set this age value to 42 where the name equals Sam. So this would be the command for that. So I will give in the update keyword and then give in the name of the table which would be employee and then use the set keyword and then set the age value to be equal to 42. Then use the where clause and then set the condition. So the condition is the name should be equal to Sam. So where the name is equal to Sam, I am updating the value of age from 45 to 42. Let me put a semicolon. Let me hit execute. So you see that one row has been affected. So now let me have a glance at the change table. Select star from employee. Right. So we see that initially the age value was 45 where the name was Sam. So the age value has been changed from 45 to 42. Now similarly, I'd want to change the department to tech wherever the gender value is female. That is, I want to change the department of all of the female employees from analytics to tech. So this is how I can do it. Again, update keyword and then I'll give in the name of the table and then the set keyword. So over here, I want to set the department to be equal to tech, where the gender is equal to female. So let me put in female over here. Right. So let me hit execute now and let's see what happens. So we see that 2 rows have been affected. Now again, let me have a glance at the modified table. Select star from, name of the table is employee. Right. So we see that initially the department of both of the female employees was analytics. So that department has been changed from analytics to tech. Now I want all of the employees to have the same salary. So I will update this entire column to have the same value, which is $50,000. So this command would be quite simple. Update and then the name of the table, which is employee, and then I'd have to set the salary to be equal to 50,000. That's it. Let me hit execute. So we see that 6 rows have been affected. Again, let me have a glance at the modified table. Select star from, the name of the table is employee. Execute again. Right. So we see that the salary has been updated. So every employee's salary is same. It is $50,000 per annum. And this is how we can work with the update state. So the delete query is basically used to delete or remove one or more existing records in the table. So let's have a look at the syntax. We'll start with the delete keyword and then put in the keyword from. Then we specify the name of a table. After that, we'll specify the where condition, but that's optional. Now let's delete some records from our employee table. So we have our employee table right here, and I'd want to delete that record where the age of the employee is equal to 33. So this would be the command for that. I will give in the delete keyword and then I'll type from and given the name of the table, which would be employee. After that, I'll use the where clause and give the condition. So the condition would be age is equal to 33. I'll put in a semicolon over here and I'll hit execute. So you see that 1 row has been affected. Now let me have a glance at the modified table. So I will type in select star from employee. Execute again. Right. So you see that record where the age was equal to 33 has been removed. So initially we had 6 records. Now we only have 5 records in our table. Now similarly, I want to delete that record where the employee name is equal to Sam. So let me write the command for that. So I will give in the delete keyword first and then I'll give in the from keyword. After that, I'll give the name of the table, employee, then use the where clause and then give the condition. So this time the condition would be name is equal to Sam. Right. Execute. Again, we have 1 row which has been affected. Select star from employee and let's see the modified table now. So see that another record has been deleted, and that record where the name was equal to Sam is the record which has been deleted. Then we have the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let me go ahead and remove all of the records from this employee table using the truncate command. So I'll type truncate table and then I'll give in the name of the table, which is employee. Execute. So see that commands completed successfully. Now I will type select star from employee. Now let's see what do we get. So we see that all of the records are empty. This is because the truncate table command basically removes all of the data from the table. And the specialty of the truncate command is, even though it removes all of the records from the table, the structure of the table remains intact. So we see that the structure of this table over here, employee table, it is still intact. So this is how we can work with the delete and truncate statements. How to implement the inner join? We'll be implementing the inner join on these 2 tables. First is the employee table, which comprises of employee ID, employee name, employee salary, age and gender, and the department in which the employee works. Then we have the department table, which comprises of department ID, department name, and the location where the department is present. So the inner join basically gives us those records that have matching values in both the tables. So let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So let's have a look at the syntax. Well, give the select keyword first and then the list of the columns, following which we'll give the from keyword and give the name of the first table. Then we'll use the keywords inner, join and give the name of the second table. After which we'll use the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to the values of column Y from the table 2. Now this might sound complicated, so let's just implement this inner join on the employee table and the department table. So before I go ahead and implement the inner join, let me have a glance at both of the tables. So I'll start with the employee table, select star from employee. Right, so this is our employee table. So we see that we have this department column over here which tells us about all of the departments in which the employees work in. Now similarly, let me have a glance at the department table. Select star from, I will give in the name of the table which would be department. Right, so we have three columns over here and I have this D name column over here which gives me all of the names of the departments. So this is the common column between the employee table and the department table. So we'll be applying the inner join condition on the D name column of the department table and the EDEPT column of the employee table. So let me go ahead with the syntax of inner join. I will give in the select keyword and then give in all of the columns which I'd want to select. So I'd want to select the ename column and EDEPT column from the employee table. So first I would have to give in the name of the table which is employee. Then I'll put dot over here and then give in the name of the column. So I want the name column from the employee table. And similarly, I'd also want the department column from the employee table. First, I will give in the name of the table. I'll put in dot over here and then give in the name of the column which is EDEPT. Right. Now I'd also want the department name column and the department location column from the department table. So first, I will give in the name of the table which is department. I'll put in dot over here and then give the name of the column which is D name. Similarly, I'd want to extract the department location column from the department table. First, I will give in department over here which is the name of the table. I'll put in dot and then I will give in the name of the column which is D underscore location. After this, I will give in the from keyword and then give in the name of the first table which would be employee. Then I will give in the keywords inner, join and give in the name of the second table which would be department, right? So I am selecting these four columns and the inner join would be on the employee table and the department table, right? Now I will use the on keyword and give the condition. So the condition would be the values of the EDEPT column of the employee table and the values of the D name column of the department table should be equal. So employee dot EDEPT should be equal to department dot D name. Right guys, so this is the complete syntax to implement inner join on these two columns of the employee table and the department table. And I am selecting the E name and E department columns from the employee table and D name and D location columns from the department table. Now let me hit execute. Right, and this is what we get. So we have these four columns over here: employee name, employee department, department name and department location. And since this is inner join, we have only those records where the values from EDEPT have matched to those values of D name. And this is how we can implement inner join. So the left join basically returns all the records from the left table and the matched records from the right table. So if we take table A and table B, then applying left join on these two tables would give us all the records from table A and only the matched records from the table B. So let's have a look at the syntax. We'll start with the select keyword and then give the list of the columns, following which we'll give the from keyword and give the name of the first table. Then we'll use the keywords left, join and then give the name of the second table. After which we'll use the keyword on. So this on keyword tells SQL that this left join needs to be done on some condition, and that condition would be values from column X of table 1 should be equal to values from column Y of table 2. So let's implement this left join on the employee table and the department table. So before I implement the left join, let me actually have a glance at both of the tables. So I'll start with the employee table. Select star from employee. And these are the columns present in the employee table. Employee ID, employee name, employee salary, employee age, employee gender, and employee department. So I'll be taking this employee department column from the employee table. Now similarly, let me have a glance at the department table. Select star from, the name of the table is department. So we have the department ID, department name, and the department location. And from this department table, we'll be selecting this D name column. So we'll be applying the left join on the EDEPT column of the employee table and the D name column from the department table. So let me start with the syntax to implement the left join. So I will give in the select keyword first, and then I will give all of the columns which I want to select. So I want to select the employee name column from the employee table. So first I will give in the name of the table, which is employee, then I'll put dot over here, and then I will type employee name. Now I'd also want the employee department column. So first I will give in the name of the table, which is employee. I'll put dot over here, and then I will give in EDEPT over here. Then I'd want the department name column and the department location column from the department table. So I will give in the name of the table first, which is department. I'll put a dot over here, and I will select the department name column from the department table. Similarly, again I will type in the table name, which is department. Then I'll put a dot over here, and then I'll also select the department location column. So now that I've selected all of the columns, let me give in the keyword from, and then give the name of the first table, which is employee. Then I'll give the keywords left join, and then give the name of the second table, which is department. Now I'll give the on keyword and then give the condition. And the condition would be the values from the employee department column from the employee table should be equal to the values of the department name column from the department table. So employee dot EDEPT, these values should be equal to department dot tname. I'll put a semicolon over here. Now let me hit execute. Right, so this is the result when we apply the left join operation on the employee table and the department table. So we've got all of the records from the left table, which is the employee table. And we see that we get only the matched records from the department table, which is the right table over here. And wherever the records haven't matched, we get null values. So we see that the operations department is not present in the department table. So that is why we have null values over here. And this is how we can implement the left join. So the right join basically returns all the records from the right table and only the matched records from the left table. So if we take table A and table B, then applying right join on these two tables would give us all the records from table B and only the matched records from table A. So let's have a look at the syntax. We'll start with the select keyword first, and then given the list of the columns, following which we'll give the from keyword and then give the name of the first table. Then we'll use the keywords right, join, and then give the name of the second table, after which we'll use the keyword on. So this on keyword tells SQL that this right join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to values from column Y of table 2. So before I go ahead and implement the right join, let me actually have a glance at the employee table and the department table. So I'll start with the employee table. Select star from employee. So this is our employee table, which comprises of these columns: employee ID, employee name, employee salary, employee age, employee gender, and employee department. And we'll be implementing the right join with respect to this column, employee department. Now let me also have a glance at the department table. Select star from, the name of the table as department. I'll hit execute. So the department table comprises these three columns: department ID, department name, and department location. And we'll be implementing the right join with respect to this D name column. So now let me go ahead and write the syntax for the right join. So I will put in the select keyword first, and then I'll give in all of the columns which I want to select. So from the employee table, I want to select the employee name and the employee department columns. So for that, I'd have to give in the name of the table first, then I'll put dot, and then I will give in the name of the column which I want to select. So employee name, Similarly, I also want the employee department column. So first I will give in the name of the table, which is employee dot, and then I'll select the EDEPT column. And then I want the department name and department location columns on the department table. So I'd have to give in the name of the table, which is department. I'll put in dot over here and then given the name of the column, which is dname. Similarly, I'd also want the department location. So I'll put dot and then select department location. Now I will give in the from keyword and then give in the name of the first table, which would be employee. After that, I will type the keywords right join and then give the name of the second table, which is department. Then I'll use the on keyword and then give the condition. So the condition would be values of EDEPT column from employee should be equal to values of dname column from the department table. So employee dot EDEPT should be equal to department dot dname. I'll put semicolon over here. Let me hit execute. And this is the result which we get when we apply right join on the employee table and the department table. And since this is the right join, we see that we have all the records from the department table and we have only the matched records from the employee table. So we see that there is no content, tech and finance departments in the employee table. So that is why we have null values over there. And this is how we can implement the right join. So the full join basically returns all the records from the left table and also all the records from the right table. So if we take table A and table B, then applying full join on these two tables would give us all the records from table A and also all the records from table B. And wherever the join condition is not met, we'll get null values in that place. So let's have a look at the syntax. We'll start with the select keyword first and then given the list of the columns. Following which, we'll give the from keyword and then give the name of the first table. Then we'll use the keywords full, join and then give the name of the second table. After which we'll use the keyword on. So this on keyword tells SQL that this full join needs to be done on some condition. And that condition would be values from column X of table 1 should be equal to values of column Y from table 2. So before I go ahead and implement the full join, let me actually have a glance at the employee table and the department table. So I'll start with the employee table first. So select start from, the name of the table is employee. So we have these columns in the employee table: employee ID, employee name, employee salary, employee age, employee gender, and employee department. And we'll be applying the full join on the employee department column. Now let me also have a glance at the department table. Select star from, the name of the table is department. I'll hit execute. So the department table has these three columns: department ID, department name, and department location. And we'll be applying the full join condition on this department name column. So let me start with the syntax for the full join. So I will give in the select keyword first and then I'll give in the list of all of the columns which I want to select. So I want to select the employee name and the employee department columns from the employee table. So first I'll give in the name of the table, which is employee, and then I'll give in the name of the column, which would be employee name. Similarly, I'd also want the employee department column. So I'll give in the name of the table, employee. I'll put dot over here and then I'll select the EDEPT column. After that, I'd also want the department name and department location columns from the department table. So I'll give in the name of the table, department. I'll put dot over here and then I'll select department name. Similarly, I'll also select the department location column. So I will give in the name of the table. I'll put dot and then I'll select the department location column. After this, I will use the from keyword and then give in the name of the first table, which is employee. Then I will use the keywords full, join, and then give in the name of the second table, which is department. After that, I will give the keyword on and then specify the condition on the basis of which the full join needs to be done. So the condition is the values of EDEPT column from the employee table should match with the values of the dname column from the department table. So that would be employee dot EDEPT is equal to department dot dname. I'll put semicolon over here. Let me hit execute. So this is the result of the full join on the employee table and the department table. So wherever we see null values, that means that the records have not matched over here. So operations is present in the employee table, but it is not present in the department table. So that is why we have null values in the columns extracted from the department table. Similarly, we have content, tech, and finance departments only in the department table. And that is why we have null values in the columns extracted from the employee table. And this is how we can implement the full join. So let's understand how can we use update with join. Here we have two tables, the department table and the employee table. Now I'd want to update the age value in the employee table wherever the department location is New York. So from the department table, we can find out that content and analytics departments are based in New York. So in the employee table, we'll update those age values where the department is either analytics or content. And after updating the table using the join statement, we see that these two values have been modified. So we have the department and employee tables right in front of us, and we'll be implementing the same task. So from this employee table, we'll add 10 more to the age values wherever the department location is equal to New York. And since we've already seen that content and analytics are based in New York, so basically these two records where the EDEPT value is equal to analytics, we'll be adding 10 more to these two age values. So let me write the syntax for that. I'll type update and then give the name of the table which I want to update. So that would be employee. After that, I'll use the set keyword and then update the age value. So age, and I'm adding 10 more to the age value. After that, I'll use the from keyword and give the name of the first table, which would be employee. Then I'll type join and then give the name of the second table, which would be department. Then I'll type on and then state the join condition. So the join condition is the values of the EDEPT column from the employee table should be equal to the values of dname column from the department table. So employee dot EDEPT should be equal to department dot dname. And finally, we'll specify the where condition, which would be D location should be equal to New York. So I'll select all of this, I'll click on execute. So you see that two rows have been affected. Now let me have a glance at the modified employee table. Select star from, I'll type the name of the table, which would be employee. Now I'll execute this. So let me see the original age values. So over here, the department is analytics, and we see that the initial age of Anne and Julia is 25 and 30. And after applying the update command, we see that the age has been modified to 35 and 40. So Anne's initial age was 25. After updating, it became 35. Similarly, Julia's initial age was 30. After updating, it became 40. So this is how we can use update with a join condition. Now let's understand how can we use delete with join. So this time from the employee table, I'll be deleting those records where the department location is equal to New York. And since content and analytics are based in New York, we'll go ahead and delete those two records from the employee table. So in the final modified employee table, we see that there are no records where the department is either content or analytics. So again, we'll be implementing the same task. From this employee table, I'll be deleting those records where the department location is in New York. So let me write the syntax for that. So I'll type delete and then give the name of the table from which I'd want to delete the records. So that would be employee. After that, I will give the from keyword and then give the name of the first table, which would be employee again. Then I'll type join and then give the name of the second table, which would be department. Now I will give on and give the join condition, which is same again. So the values of EDEPT column from the employee table should be equal to the values of dname column from the department table. So employee dot EDEPT should be equal to department dot dname. And finally, I'll use the where condition, which would be D location should be equal to New York. So I'll select all of this. I'll click on execute. So again, we see that two rows have been affected. Now let me have a glance at the modified table. Select star from employee. So see that there are no records where the department is analytics. So if you have a look at the original table, we see that there are two records where the employees were present in the analytics department. And after deleting those two records, we just have 4 records present in the employee table. And this is how we can work with update and delete statements using join. So the union operator is used to combine the result set of two or more select statements. For example, if the first select statement returns these 4 fish and the second select statement returns these 3 fish, then the union operator would return the result set of these two select statements. And if there is a record which is present in both the tables, we'll get only one of them in the final result. That is, there would be no duplicates in the final result. So here we see that this blue fish is present in both the tables A and B. But in the final result of A union B, we'll get only one of the value. And this is the syntax for the union operator. We'll give the first select statement. After that, we'll give the union operator. Following which, we'll give the second select statement. Now, you also need to keep in mind that the number and order of columns must be same in both the select queries. And we'll be implementing the union operator on these two tables. So we have the student details 1 table, which has the columns SID, SName and SMarks and has these 4 records. The other table is student details 2, which has the same columns and comprises of these 3 records. So let's go to SQL Server and work with the union operator. Right, so we have our 2 tables right in front of us. So let me start with the syntax. I'll get the first select query. Select start from and then I'll give the name of the table, which is student details 1. After that, I'll give the union operator and then give the next select statement. Select star from and then the name of the table is student details 2. I'll select all of this. I'll hit execute. So the union operator has given us the result set of both of the select statements. Then we have the union all operator. The union all operator gives all the rows from both the tables, including the duplicates as well. So here, since the blue fish is present in both the tables A and B, the final result of A union all B will also have the duplicate value. So now let me just add the all keyword over here. So I am using the union all operator between these two tables. Now I'll hit execute. So we see that we also have the duplicate values. So here, these records where Anne and Julia are present, these are from the first table. And again here, Anne and Julia, so these records are from the second table. So we have also got the duplicate records this time because we've used the union all operator. Now again, let me remove this all keyword, let me hit execute. So you see that there are no duplicates this time. So this is a difference between union and union all operators. So this is how we can work with the union and union all operators. So the except operator combines two select statements and returns unique records from the left query which are not part of the right query. For example, if the first select statement returns these 4 fish and the second select statement returns these 3 fish, then the except operator would return us these 2 fish which were part of the first select statement but not the second select statement. And this is the syntax of the except operator. We'll give the first select statement. After that, we'll give the except operator. Following which, we'll give the second select statement. Now you also need to keep in mind that the number and order of columns must be same in both the select queries. And we'll be implementing the except operator on these two tables. So we have the student details 1 table which has the columns SID, SName and SMarks and has these 4 records. And the other table is student details 2 which has the same columns and comprises of these 3 records. So let's go to SQL Server and work with the except operator. Right, so we have our 2 tables right in front of us. So let me type in the syntax. I will give the first select query which is select star from and then I'll give in the name of the table which is student details 1. After that, I will use the except operator and then give in the second select statement. Select star from the name of the table is student details 2. I'll select all of this again. I'll hit execute. So this is the result of the except operator. So these are the 2 records which were part of the first select statement but not the second select statement. And this is how we can work with the except operator. So the intersect operator helps to combine 2 select statements and returns only those records which are common to both the select statements. And this is the syntax for the intersect operator. We'll give the first select statement, after which we'll give the intersect operator, following which we'll give the second select statement. So this intersect operator basically retrieves the common records from both the left and right side of the intersect operator. Now you also need to keep in mind that the number and the order of the columns must be same in both the select queries. And we'll be implementing the intersect operator on these two tables. So we have the student details 1 table, which has the columns SID, SName and SMarks and has 4 records. The other table is student details 2, which has the same columns and comprises of 3 records. So let's go to SQL Server and work with the intersect operator. So these are our two tables over here. This is the student details 1 table and this is the student details 2 table. Now let me implement the intersect operator on these two tables. So I will give in the keyword select star from and then give the name of the table, which would be student details 1. After that I will give the intersect operator intersect and then give the second select statement. Select star from student details 2. Right guys, so this is pretty much the syntax. So we'll give the first select statement, after that we'll give the intersect operator and then we'll give the second select statement. Now let me select all of this, let me hit execute. So these are the two records which are common to both the student details 1 table and also the student details 2 table. And this is how we can work with the intersect operator. So views are virtual tables which are used to limit the information that we want to display. And these are actually nothing but the result of an SQL statement which have a name associated with them. For example, from this employee table, let's say we wanted to perform multiple operations on the records where the gender is female. So we can create a view for only the female employees from the entire employee table. So let's have a look at the syntax to create a view. We'll start off by using the keywords create view, then give the name of the view. After which we'll give the keyword as and then give the list of the columns which you want to select from the table. So let's actually create a view from our employee table. So I don't create a view which would comprise of only the female employees from the entire employee table. So this would be the command for that. Create view, then I'll give the name of the view, which would be female employees. After that I will give in the keyword as and I will select all of the columns from the employee table. So select star from employee, then using the where clause I will give in the condition. So the condition would be e gender is equal to female. So I'll put a semicolon over here. I'll hit execute. So you see that commands have been completed successfully. So now let me have a glance at the female employees view. Select star from, I'll give the name of the view which would be female employees. I'll put a semicolon, hit execute. Right? So we see that we have successfully created a view from the employee table, and in this view we have only 2 records which comprise of the employees Anne and Julia, and both of them are obviously female. Now let's see how can we drop a view. So the syntax for dropping a view is pretty simple. All we have to do is give the keywords drop view and then give the name of the view. So let me drop this female employees view. I will type in drop view and then I will give in the name of the view which is female employees. I'll put a semicolon, execute. So again commands have been completed successfully. So now let me see if the view exists or not. Select star from female employees, execute, and this is the result which we get. Invalid object name female employees, and we get this because the view female employees has been dropped. So this is how we can work with views. So the alter table statement is used to add, delete and modify columns in an existing table. Now let's have a look at the syntax to add a column to an existing table. So we'll start off by giving the keywords alter table, then we'll give the name of the table. After that, we'll give the add keyword and the name of the column which we want to add to our table. And finally, we'll have to assign a data type to this new column. So to our existing employee table, I'll add a new column, date of birth, using the alter table statement. So let me start with the syntax, alter table, then I'll give the name of the table, which would be employee. After that, I will give in the add keyword and then give in the name of the column. So I'll name the new column to be EDOB, which would stand for employee date of birth. And then I'll finally give the data type of this new column. So the data type would be date. So I'll put a semicolon. I'll hit execute. So commands have been completed successfully. Now let me have a glance at the modified table. Select star from employee. Right. So we see that this new column, employee date of birth, has been added. So you see that this new column, employee date of birth, has been added to our employee table. Now let's see how can we drop a column from a table. Again, we'll start off by giving the keywords alt table, and then we'll give the table name. After that, we'll give the keywords drop column and specify the name of the column which is to be dropped. So I want to drop this new column which I have just added to this employee table. So let me write the command for that. So I want to drop this new column EDOB which I have just added to this employee table. So let me write the command for that. Alter table, and then the name of the table is employee. Alter table, and then the name of the table is employee. After that, I will give in the keywords drop column, and I want to drop the EDOB column from this employee database. I'll put a semicolon, hit execute. So again, the commands have been successfully executed. Now let me have a glance at the modified table. Select star from employee. I'll put a semicolon, execute. So again, the new column which you had just added has been dropped. So this is how we can work with the alter table statement. So the merge statement helps us to perform insert, update and delete in just one statement. This means we no longer require multiple statements to perform insert, update and delete. And for the merge statement, we require two tables, a source table and a target table. So the source table basically contains all the changes which are to be applied to the target table. And the target table is that table upon which we'll be implementing all the changes. Now the merge statement basically joins the target table to the source table using a common column in both the tables. And based on how the rows match up, we can perform insert, delete and update operations on the target table. Now let's have a look at the syntax of the merge statement. So we'll start with the merge keyword and then give the name of the target table and assign it an alias using the as keyword. Then we'll type using and give the name of the source table and also assign it an alias using the as keyword again. After that, we'll type on and then set the join condition. Then we'll type when matched. So if the rows match up based on the join condition, then we'll go ahead and update the target table. After that, we check when not matched by target. So this basically means that if there are some rows which are present in the source table but not in the target table, then we'll go ahead and insert those rows from the source table into the target table. And finally, we check when not matched by source. So here we are checking if there are some rows which are present in the target table but not in the source table, then we'll go ahead and delete those rows from the target table. And for the practical purpose, we'll be using these two tables. So this is our source table with the name employee source, and this is our target table with the name employee target. So using the merge statement, we'll be updating the e-salary and e-age columns in the target table wherever there's a match. Also, insert the records with employee ID 7 and employee ID 8 into the target table from the source table. And delete the records with employee ID 4 and employee ID 5 from the target table because they're not present in the source table. So let's go to SQL Server and work with a merge statement. Right, so we have our two tables right in front of us. This is the employee source table and this is the employee target table. And we also have the merge syntax to apply on these two tables. So we'll type merge and then give the name of the target table, employee target. We'll assign it an alias T. Similarly, we'll give the employee source table and then assign it an alias S. After that, we'll type on and then set the join condition. So the join condition is t.eid is equal to s.eid. So we basically set the join condition on the employee ID columns of the source table and the target table. Then we have when matched. So if there is a match between the rows of these two tables, then we'll go ahead and update the target table. So here in the update statement, we have t dot e salary equals s dot e salary and t dot e age is equal to s dot e age. So if the records match, then I'll be setting the values of the salary column of the target table to be equal to the values of the salary column of the source table. Similarly, I'll also set the values of the age column of the target table to be equal to the values of the age column of the source table. And then we have when not matched by target. So here we are checking if there are some rows which are present in the source table but not in the target table. And if that is the case, we'll go ahead and insert all of those into these columns of the target table. And the values would be coming from the source table. So this employee ID column from the target table would be getting the values from the employee ID column of the source table. Similarly, this employee name column of the target table would be getting its values from the employee name column of the source table. And finally, we'll check when not matched by source. So if there are some rows which are present in the target table but not present in the source table, then we'll just delete all of those rows. So I'll select all of this and I'll click on execute. So we see that 8 rows have been affected. Now let me type the select statement and have a glance at the modified employee target table. Select star from employee target. I'll select this. I'll click on execute. Right, so this is our modified employee target table. So we also have our original employee target table over here. So let me compare these two tables. So we see that initially Sam's salary was $95,000 and his age was 45. And after applying the merge statement, his salary changed to $93,000 and his age changed from 45 to 40. Similarly, Anne's initial salary was $125,000 and after applying the merge statement, her salary changed to $130,000. And then with the merge statement, we have also inserted the records with employee ID 7 and employee ID 8 and deleted these two records from the employee target table. So this is how we can work with the merge statement. So these are the two types of user-defined functions in SQL. We have scalar-valued functions and table-valued functions. We'll start with the scalar-valued functions. So as the name states, a scalar-valued function always returns a scalar value. So a scalar value could be int, varchar, date and so on. And this is the syntax for a scalar valued function. So we'll type create function and then we'll give the function name. And inside the parenthesis, we'll specify the names of the parameters and their data types. And since the function is going to return a value, we'll type the returns keyword and specify the type of data which will be returned. After that, we'll type as begin and then give the function body and then return the final scalar value. Finally, we'll use the end keyword to end the function. So let's go to SQL Server and create our first scalar valued function. So I'm going to create a scalar valued function which will take one integer value, add 5 more to the original value and return the updated value. So let me type the syntax for that. Create function and then I'll give the function name which would be add 5. And inside the parenthesis, I'll pass the first parameter. So I'll name the parameter to be num and this would be of integer type. After that, I'll type the returns keyword and then the type of data which we'll be returning is also of integer type. After that, I'll type as begin and since all we have to do is add 5 more to the original value, so I'll not write anything inside this. So I'll directly type the return keyword and inside this return keyword I will add 5 more to the parameter value. So that would be @num plus 5. So what we are basically doing over here is the value which is sent as parameter inside this function, will take it and add 5 more to that value and then return it. And finally, I'll type the end keyword to end this function. So let me hit execute. Right, so we have successfully created this add 5 function. Now let me go ahead and call this function. So to call the function, I'll type select and then I'll have to type dbo dot and then I'd have to give the function name, which is add 5. Now let's say I'll pass in the number 10. I'll select this, I'll hit execute. Right, so we see that this function works properly. So I've sent 10 and the result which we've got is 15. Similarly, let me send 100 as the parameter. Now I'll select, I'll hit execute. Right, so the value which is returned is 105. So this is how we can create a scalar valued function. Then we have table valued functions. So these table valued functions return a table instead of a scalar. And this is the syntax for a table valued function. So here the return type is table. So after the returns keyword, we'll type in table because we are supposed to return a table. After that, we'll give the keywords as return and then give in the select statement. Now you need to keep in mind that there are no begin and end keywords for the table valued function. So let's go to SQL Server and create our first table valued function. Now I'll be creating a function which would help me to individually extract the male employees and the female employees from the employee table. So before I do that, let me actually have a glance at the employee table first. So I'll type select star from employee. Right, so we have this employee table right in front of us. Now let me go ahead and create the command. So again, I'll type create function and then I'll give the name of the function, which would be select gender. Now inside the parenthesis, I will pass in the parameter. So I'll name the parameter to be gender and this would be of varchar type. So as varchar and the length would be 20. After that, I'll give the returns keyword, and since this is a table valued function, the return type would be table. So I'll type as return and then give in parenthesis, and inside the parenthesis I will give my select statement. So the select statement would go something like this: select star from employee where gender is equal to @gender. So this gender is basically the gender column from the employee table, and this @gender is the parameter which will be passing inside this function. So let's say if the user passes the value male inside this function, then we'll be extracting all of the records where the gender value is male. Similarly, if the user passes the value female inside this, then we'll be extracting all of the female employees from this table. So let me select this, let me hit execute. Right, so we have also created this select gender function. So now using this function, let me extract all of the male employees from the employee table. So to do that, the syntax would be a bit different. Select star from and then I'll type dbo dot and then give the name of the function, which would be select gender, and inside the parenthesis I will pass in the value, and since I want all of the male employees, I'll type male over here. Right, so I'm typing select star from this because this will basically return a table, and from the table which is returned I would want all of the records. So let me select this, I'll hit execute. Right, so we have successfully extracted all of the male employees from the employee table. Similarly, if I'd have to extract all of the female employees, the syntax would be similar. So I'll type select star from and then I'll type dbo dot select gender and then I will pass in the value female. I will select this, I'll hit execute. So again, we have successfully extracted the female employees from the employee table. So this is how we can create table valued functions in SQL. So temporary tables basically help us to store and process intermediate results. Now these temporary tables are created in the temp DB and are automatically deleted when they're no longer used. So the temporary tables could be very useful in cases wherever we need to store temporary data. And this is the syntax to create a temporary table. So first we'll give the keywords create table, and before we give the name of the temporary table, we'll precede it with a hash. So this hash symbol basically signifies that the table which we are creating is temporary. So let's work with some temporary tables now. So let me create a temporary table with the name student, which has two columns. One is student ID, another is a student name. So I'll type create table I'll put in the hash symbol and then give the name of the temporary table, which would be student. So now this would have just two columns. First would be student ID, so SID, and this is of integer type. Then we have the student name, so I'll name the column as S name, and this is of variable length character of maximum length 20. So I'll put a semicolon over here and I'll hit execute. Right, so we see that the commands have been completed successfully. Now I've already stated that this temporary table is stored in the tempdb. So let me show you guys where the tempdb is actually. So you'd have to click on the system databases, and over here you will see the tempdb, and inside tempdb you have all of the temporary tables. So let me refresh this. Right, so we see that we have this temporary table student inside our tempdb database. Now similarly, I can also use the select statement with this temporary table which I've created. So I'll type select star from, and before giving the name of the table, I need to give the hash symbol and then give the table name, which would be student. Right, so let me select this and I'll click on execute. Right, so this is our table and we don't see any values because we haven't inserted any into this table. So similarly, we can also use the insert command and insert some values into this temporary table. So I'll type insert into, after that I'll give the hash symbol and then give the name of the temporary table, which would be student. I'll follow it up with the values keyword and then give the values which are to be inserted inside this. So first is the student ID, which will be 1. Then I'll give the name of the student. So name of the student is Sam. So again, I will select this and I'll click on execute. So one row has been effected. Now I'll select this line again and I'll hit execute. Right, so we have successfully inserted this record inside our temporary table student. So this is how we can work with temporary tables in SQL. So the SQL case statement helps us in multi-way decision making. So let's take this example to understand case statement properly. Let's say there are 10 buttons starting from 1 to 10. So if the person selects 1, then he wants tea. If he selects 2, then he wants to order coffee. Similarly, if he selects 3, then he wants milk. And for any other case, the person will order water. So this is basically how the case statement works. So the case statement goes through conditions and returns a value when the first condition is met. And this is the syntax for the case statement. So we'll type in case, following which we'll give the when keyword and give the first condition. After that, we'll type then and specify what will happen if this condition is satisfied. And we'll do the same for the rest of the conditions. After that, we'll type else and state what will happen if none of the above conditions are satisfied. Finally, we'll give the end keyword. So now let's go to SQL Server and start working with the case statement. So I'll check some conditions using the case statement. So first I'll check if 10 is greater than 20, and if this evaluates to true, I'll just print 10 is greater than 20. After that, I'll check if 10 is less than 20. And if this condition evaluates to true, I'll print 10 is less than 20. And if none of these two conditions evaluate to true, I'll just print 10 is equal to 20. So let me write the syntax for that. Select, I'll give the case statement, then type when and give the first condition, which would be 10 is greater than 20. I'll type then and state what will happen if this condition is evaluated to true. So I'll just print 10 is greater than 20. Then I'll type when and then state the second condition, which would be 10 is less than 20. I'll type then, and if this condition evaluates to true, I have to print 10 is less than 20. And if none of these conditions evaluate to true, I'll type else and just state 10 is equal to 20. And I'll finish off the case statement with the end keyword. So let me hit execute. So we get the result, 10 is less than 20. So we get this result because the first condition has been evaluated to false. Because obviously 10 is not greater than 20. And since 10 is less than 20, this has been evaluated to true and we print 10 is less than 20. So now let's also implement this case statement on top of our employee table. So before we do that, let us actually have a glance at the employee table. So I'll type select star from employee. Right, so this is our employee table. Now using the case statement, I would want to add a new column, grade, which would be dependent on the salary column. So if the salary is less than $90,000, the grade would be C. If the salary is between $90,000 and $120,000, the grade would be B. And if the salary is greater than $120,000, the grade would be A. So let me write the syntax for that. So I'll type select, and I want all of the columns from the employee table. I'll type star, and I'll add a new column grade, and I'll be getting the values in this column with the help of the case statement. So I'll type case, and then type the when keyword and give the first condition. So the first condition would be E salary is less than $90,000. And if this evaluates to true, the grade would be C. I'll type when and say the second condition. So the second condition would be if E salary is less than $120,000. So here, if the first condition is evaluated to false, then it would mean that the salary is greater than $90,000. And after that, we'll check if the salary is between $90,000 and $120,000. And if that evaluates to true, the grade would be B. And if none of these conditions evaluate to true, that would mean the salary is greater than $120,000. So I'll type else, and then the grade which I want is A. And I'll finish off this case statement with the end keyword. And I want all of this from the employee table. So I'll type from, and then give the name of the table, which would be employee. I'll type go, I'll select all of this, and I'll hit execute. Right, so we see that this new column grade has been added to the employee table, and this grade column is dependent on the salary column. So here we see that the salary is between $90,000 and $120,000. That is why the grade is B. Here the salary is less than $90,000. The grade is C. And over here the salary is greater than $120,000. That is why the grade is A. So this is how we can work with a case statement in SQL Server. So the if function is an alternative to the case expression. This if function takes in a Boolean expression as the first parameter and returns the true value if the Boolean expression is evaluated to true. Similarly, returns the false value if the Boolean expression is evaluated to false. For example, let's say in the Boolean expression we are checking if the marks scored by a student are greater than 50. And if it evaluates to true, we'll return pass. And if the Boolean expression evaluates to false, we'll return fail. So this is how the if function works. Now let's implement this if function in SQL Server. So using the if function, I'd want to check if 10 is greater than 20. And if it evaluates to true, I'll print 10 is greater than 20. On the other hand, if it evaluates to false, I'll print 10 is less than 20. So let me write the syntax for that. I'll type select. After that, I'll use the if function and pass in the first parameter, which is the Boolean expression. So 10 is greater than 20. And if it evaluates to true, I would want to print 10 is greater than 20. On the other hand, if it evaluates to false, I would want to print 10 is less than 20. I'll hit execute. Right, so what we get is 10 is less than 20. So we get this result because this Boolean expression has been evaluated to false, and it is redirected over here, and we get the false result, which is 10 is less than 20. Now I'll go ahead and also implement this if function on top of the employee table. So before I do that, let me actually have a glance at the employee table first. So I will type select star from employee. So we have our employee table right in front of us. Now using the if function, I'd want to add a new column employee generation, and that new column would be dependent on this age column. So if the age of the employee is greater than 30, then the new column would have a value old employee. Similarly, if the age of the employee is less than 30, then the value in the new column would be young employee. So let me write the syntax for this. I will type select and list down all of the columns which I want from the employee table. So I want the employee ID column, employee name column, employee age column. Now after this, I will use the if function to add the new column. So I'll give the first parameter, which would be the Boolean expression. So here I will check if E of age is greater than 30. And if the age is greater than 30, I would want the value to be old employee. On the other hand, if the age is less than 30, I would want the value to be young employee. Now I will name this new column as employee generation. So let me just type the name of the column employee generation over here. And I would want all of this from the table employee. Now I'll select this I'll hit execute. Right. So we see that a new column has been added to this, and the name of this column is employee generation. So here, if we have a glance at this age value, it is 45, and the corresponding value in employee generation is old employee. Similarly, here it is 21, and since the value is less than 30, we get young employee. And these two, it is 25 and 30. And since these two values are also not greater than 30, we have young employee over here. And Matt, whose age is 33, we have the value old employee. And we have Jeff, whose age is 27, he's a young employee too. So this is how we can work with the if function in SQL. So a stored procedure is basically a prepared SQL code which we can save so that the code can be reused again. So if we have an SQL query that we write over and over again, we can save it as a stored procedure and then just call it whenever we want. Now let's have a look at the syntax of the stored procedure. So we'll give the keywords create, procedure, and then give the procedure name. After that, we'll give the keyword as, and then give the SQL statement for which we need to create the procedure. And we'll end the procedure with the go keyword. Now, after we create a procedure, we need to execute it. So this is the syntax to execute the procedure. We'll type exec and then give the name of the procedure which is to be executed. So let's go to SQL Server and work with some procedures. So now I'd want to create a procedure which would help me to easily access this age column from the employee table. So I'll type create procedure and then I'll give the name of the procedure which would be employee age. I'll type as and then give the SQL statement which would help me to access this age column. That would be select age from the name of the table is employee and then I'll give the go keyword. Now I'll hit execute. Right, so we see that we have successfully created the employee age procedure. Now I will use the exec keyword and then call this procedure. So the name of the procedure is employee age. I'll select this line, I'll hit execute. Right. So with this employee age procedure, we can easily access the age column from the employee table. Now similarly, I'll create another procedure which would help me to access all of the records from the employee table. Create procedure and I'll name this procedure as employee details. I'll follow it up with the as keyword and then give the SQL statement which would help me to access all of the records from the employee table. Select star from employee and again I'll finish this procedure off with the go keyword. I'll select all of this, I'll hit execute. So again we have successfully created the employee details procedure. Now to call this procedure, I'll use the exec command and then pass in the name of the procedure which is employee details. So I'll select this, I'll hit execute. Right. So with the help of employee details procedure, we can easily access all of the columns and all of the records from this employee table. Now we can also pass parameters to the procedure. So the syntax for this is just slightly different. Here after giving the procedure name, we follow it up with the list of parameters and their corresponding data types. So let's create a procedure with a parameter now. So now I'll create a procedure which would help me to access the male employees and the female employees separately from this employee table. Create procedure and I'll name this procedure to be employee gender. After this I will pass in the parameter. So the name of the parameter would be gender and it is of variable length character with a maximum length of 20. I will give the as keyword after this and then pass in the statements which would help me to individually access the male employees and the female employees. Select star from the name of the table as employee. I'll follow it up with the where clause and give the condition. So this time the condition would be gender is equal to @gender. Now let's understand this properly. So here gender is basically this column and we are passing in the value of this parameter to this column. So let's say when we call this procedure and the value is female, then we'll get all of the female employees. And similarly, if the value is male, then we'll get all of the male employees. Now let me finish off this procedure with the go keyword. Right, so we have successfully created this employee gender procedure. Now let me go ahead and execute this procedure. So I'll type exec and then give the name of the procedure, which would be employee gender. And now let's say I would want all of the male employees. So I will give in the parameter name @gender, and I will give in the value which would be equal to male. So let me execute this now. Right, so I've got all of the male employees from the employee table. Similarly, if I wanted all of the female employees from the employee table, this would be the command for that. Execute. I will give in the name of the procedure, which would be employee gender. I will give the name of the parameter, which would be @gender, and then pass in the value. So this time I would want all of the female employees, so the value would be female. I'll select this, I'll hit execute. Right. So this time we've got all of the female employees from the employee table. So this is how we can work with stored procedures, either with parameters or without parameters in SQL. So an error condition during a program execution is called as an exception, and the mechanism for resolving such an exception is known as exception handling. And we can do exception handling in SQL with the help of try-catch blocks. So the try statement allows us to test a block of statements while they're being executed, and the catch block allows us to handle any exception which occurs in the try block. Now let's have a look at the syntax of the try-catch block. So we'll give the keywords begin, try, and then give the statements which are to be tested. After that, we'll end the try block and begin the catch block. And inside the catch block, we'll either print the error or roll back the transaction. And we'll end the catch block as well. So let's go to SQL Server and do some exception handling. So I'll be declaring two variables and divide one of the variables with 0. So this needs to give us divided by 0 exception. So let's go ahead and handle this exception now. So we can declare a variable in SQL by using the declare statement. So I'll type declare and then use the symbol to declare a value. And I'll name this variable as val1, and this is of integer type. Similarly, let me go ahead and declare the second variable. I'll type declare and the name of this variable is val2, and the data type is integer again. Now I'll begin the try block. I'll type begin try, and then inside this I will set the values for both value 1 and value 2. So I'll use the set keyword, and then the value which I'll be assigning to val1 is 8. I'll put semicolon. Similarly, let me assign something to val2 as well. So set @val2. Now inside val2, what I'll basically do is divide val1 with 0. So now this statement should basically give us the error. So when we divide any integer value with a 0, we'll get an indefinite value. So this is the statement which will be giving the error. Now I will end the try block and try. Right. Now after this, we'll begin the catch block. Begin, catch, and inside the catch block, I will just print out the error which occurred in the try block. And I will display the default error message. And I will end the catch block as well. So let me hit execute now. So the default error message which you get is divide by 0 error encountered. So what we basically did with the set of statements was we encountered an error within the try block and we handled that error inside the catch block. So inside the catch block, we sent a default error message, and the default error message was divide by 0 error encountered. Now we can also create user defined messages. So let's go ahead and create some user defined messages. And for that purpose, I'll be doing exception handling on top of the employee table. So let me actually have a glance at the employee table first. Select start from, the name of the table is employee. Right, so we have this employee table right in front of us. So now what I'll do is I'll try to add the salary column and the name column. Now the problem with this is we cannot add a numerical column with a string value. So let's handle this exception. So I'll type begin try, and then I will give the select keyword and I will try to add salary column with the name column. And I want this from the employee table. I will end the try block. After this, I need to begin the catch block. So begin, catch. Now inside this, I will print a user defined message. So print, and I would want to print cannot add a numerical value with a string value. I will end the catch block as well. After this, I will give the go statement. Let me hit execute. So this is the message which we get. Cannot add a numerical value with a string value. And we got this user defined message because we had encountered an error inside the try block. So this is how we can do exception handling in SQL. So a transaction is basically a group of commands which change data stored in a database. And a transaction is treated as one single unit. So this transaction basically ensures that either all of these commands are executed successfully or none of them is. So let's say if one of the commands in the transaction fails, then all the commands will fail and any data which was modified in the database will be rolled back. Similarly, if all the commands inside the transaction execute successfully, only then the transaction will be committed. So this is how transactions ensure integrity of data. So now I'll begin a transaction, and inside that transaction, I'll try to update this age value from 45 to 30. So let me write the syntax to begin a transaction. So I'll type begin and then type transaction. And inside this, I'll give all of those SQL statements which either have to be committed or rolled back. So over here, I'll give the update statement. I'll type update and then give the name of the table, which would be employee. Set age to be equal to 30, where name is equal to Sam. So I'll select these two statements and I'll execute them. So we see that one row has been affected. So now let me have a glance at the modified table. So I'll type select star from employee. I will select this command over here. I'll execute this. Right, so we see that initially the age value was 45, and after we applied this update command, the age has been changed from 45 to 30. Now since this command is inside a transaction, we have the option to either roll back this command or commit this command. So now let me go ahead and actually roll back this transaction. So to do that, I'll type rollback transaction. So now let me select this. I'll click on execute. So we see that the commands have been completed successfully. Now let me again have a glance at the employee table. Right. So since we have rolled back the transaction, we see that the age value has gone back to the original value, which is 45. So initially using the update command, we had changed the age value from 45 to 30, and after that we had rolled back the transaction. Now what I'll do is, I'll execute these two statements again, and let me have a glance at the table. Right, so again we see that the age has been changed to 30. So this time, instead of rolling back the transaction, I will commit the transaction. So I'll type commit transaction. So I'll select this. I'll click execute. Now let me have a glance at the table. So this time the transaction has been committed and the change is permanent. So this is how we can either commit or roll back the commands using a transaction. Now let's look at another example. So in this example, we are using transactions inside the try catch block. So over here, we are beginning the try block, and inside this, we are beginning the transaction. And inside the transaction, we are trying to update the salary value to be equal to 50, where the gender value is equal to male. So wherever the gender is equal to male, we'll update that salary value to be equal to 50. Similarly, wherever the gender value is equal to female, I will change that salary value to be 195 divided by 0, which would give us an undefined value. And after that, we'll commit this transaction and print transaction committed. Now since we have put this transaction inside the try block, if any error occurs, that will be sent to the catch block and we will roll back the transaction. So over here, we see that we are dividing 195 with 0. And since this gives us an undefined value, we will get an error. And that error will be handled in this catch block and we will roll back the transaction. So let me execute this. So you see that the transaction has been rolled back because we get an error inside the try block. Now what I'll do is, I will remove this divided by 0 and run this command again. So this time we see that the transaction has been committed because there was no error inside the try block. So now let me have a glance at the modified employee table. So I'll type select star from employee. I'll select this. I'll click on execute. Right.
So we see that we have changed the salary value to be 50 where gender is equal to male. Similarly, I have changed the salary value to be equal to 195 where the gender is equal to female. This is how we can work with transactions in SQL.
So, who is a database administrator? Well, a database administrator is someone who directs or performs all activities related to maintaining a successful database environment. So, now that we know who is a DBA, let's look at some of the roles of database administrator. So, a DBA has to take care of the initial installation and configuration of a new Oracle or SQL Server database. The system administrator sets up hardware and deploys the operating system for the database server. Then the DBA installs the database software and configures it for use. As updates and patches are required, the DBA has to handle this ongoing maintenance. A DBA has to also take care of backup and recovery of databases. So DBAs have to create backup and recovery plans and procedures based on industry best practices that make sure the necessary steps are followed. Another role of DBA is to maintain security of the database. So a DBA needs to know potential weaknesses of the database software and the company's overall system and work to minimize risks. In case of a security breach or irregularity, the DBA can consult audit logs to see who has done what to the data. The DBA has to also take care of access control. That is, he has to verify which users can be granted access to the system and which users should be denied. Then a DBA has to also monitor databases for performance issues. So if some part of the system is slowing down the processing, the DBA may need to make configuration changes to the software or add additional hardware capacity. So now that we know what are the roles of a DBA, let's look at the types of DBA. Let's start with production DBA. So a production DBA is responsible for maintaining databases within an organization. The production DBA often gets involved when all the design decisions have been made and he or she has to keep things up and running. So the production DBAs basically take over after applications have been created and they would have to keep the server running smoothly, back it up and plan for future capacity needs. Then we have application DBA. So an application DBA focuses on a specific business application. He or she would be an expert in SQL and would implement the application business logic using SQL or any other query language. They would be also responsible for performance tuning of the database application. Next, we have development DBA. So the development DBA focuses on tasks related to building an effective, usable database environment to support the creation and maintenance of applications. Development DBAs need to be skilled in the process of data modeling and normalization to ensure that databases are designed to promote data integrity. Then there's UAT DBA. So a UAT database actually stands for Under Application Testing Database. And the UAT DBA is completely responsible for the testing and development of UAT database. And finally, we have Data Warehouse DBA. So a warehouse DBA is responsible for analyzing and understanding the data provided. It is his responsibility to study and track patterns for analytics and business intelligence. Hence, a warehouse DBA handles a more significant amount of data for a more critical function. Now let's understand what is MS SQL Server. So Microsoft SQL Server is a relational database management system or RDBMS that supports a wide variety of transaction processing, business intelligence and analytics applications. So Microsoft SQL Server is built on top of SQL. It is tied to Transact SQL or TSQL, which is an implementation of SQL from Microsoft that adds a set of proprietary programming extensions to the standard language. Now let's look at the evolution of SQL Server. So the SQL Server database platform that we know today began with the SQL Server 7.2 release in 1998. So Microsoft re-architected the core database engine code in SQL Server 7.2 to address the database's scalability issues, transforming it from a departmental database into a true enterprise level database. Perhaps even more important, Microsoft added OLAP services which would eventually become SQL Server Analysis Services. Then the SQL Server 2000 release saw Microsoft continuing to push the platform into enterprise. This release boosted scalability through large memory and address windowing extension support. The company also expanded SQL Server's data handling capabilities with the new XML data type. And then came SQL Server 2005, which was a major milestone. Microsoft added CLR integration. Plus, this was the first release to include the popular SQL Server reporting services subsystem out of the box. Microsoft also had replaced data transformation services with the new SQL Server integration services in this release. And in SQL Server 2008, Microsoft refined SQL Server's enterprise capabilities, adding transparent data encryption as well as the file stream and geospatial data types. SQL Server 2008 was also the first release with built-in row and page compression for tables and indexes. Then came SQL Server 2012, which expanded SQL Server's BI capabilities with the addition of Power View, which is a graphical data navigation and visualization tool. In this release, Microsoft also added always on availability groups, which extended SQL Server's high availability and disaster recovery options. The next release was SQL Server 2014, which provided a new in-memory capability for tables that could fit entirely in memory. It also provided a new hybrid disaster recovery and backup solutions with Microsoft Azure, enabling customers to use existing skills with the on-premise version of SQL Server to take advantage of Microsoft's global data centers. Then SQL Server 2016 released, which added new built-in JSON support in SQL Server for JSON imports, exports, parsing, and storing. A new poly-based query engine was also added to integrate SQL Server with external data in Hadoop or Azure Blob storage. And the latest release is SQL Server 2017. And with this release, SQL Server is no longer just a Windows-based RDBMS. We can now develop applications with SQL Server on Linux, Windows, Ubuntu, or Docker and deploy them on these platforms. This release also has support for Python. So our data scientists can now more easily perform machine learning right inside of SQL Server. Now let's look at the different editions of SQL Server. So first we have the Enterprise Edition. So SQL Server Enterprise Edition includes both the core database engine and add-on services, and with a range of tools for creating and managing a SQL Server cluster. So it can manage databases as large as 524 petabytes, and it supports 640 logical processors. Then we have the Standard Edition. The SQL Server Standard Edition includes the core database engine along with the standalone services. So it differs from the Enterprise Edition in that it supports fewer active instances, that is, fewer number of nodes in a cluster, and it also does not include some high availability functions such as hot add memory and parallel indexes. Then we have the Web Edition, which is just a low TCO option for web hosting. And then we have the Developer Edition. So this edition includes the same features as Enterprise Edition, but it is limited by the license to be only used as a development and test system and not as a production server. And finally, we have the Express Edition. So it is basically a scaled down free edition of SQL Server, which includes the core database engine. While there are no limitations on the number of databases or users supported, it is limited to using one processor, 1 GB memory, and 10 GB database files. Now let's learn about instances. So you can consider an instance to be one complete installation of SQL Server, and each instance manages several system databases and one or more user databases. So an instance is either the default unnamed instance or it is a named instance. A default instance does not require a client to specify the name of the instance to make a connection, but a named instance is identified by the network name of the computer plus the instance name that you specify during installation. So the client must specify both the server name and the instance name when connecting. And a computer can have only one default instance and all the others must be named. Now let's go ahead and install SQL Server into our systems. So we can install SQL Server from this site over here, Microsoft SQL Server downloads. So I'll click on this link. So this is the website. And for this course, I'll be using the Developer Edition. So all I have to do is click on download now. and it'll be downloaded. Now let's look at the different system databases in SQL Server. So when we install Microsoft SQL Server, the system databases are automatically created on every SQL Server instance. These system databases allow the database engine and administrative applications to properly manage the system. And these are the available system databases: master, model, MSDB, and tempdb. So let's start with master database. The master database contains all of the system level information for SQL Server, all of the logins, linked servers, endpoints, and other system wide configuration settings. The master database is also where SQL Server stores information about the other databases on this instance and the location of their files. So if the master database is not present, SQL Server cannot start. Then we have the model database. So the model database is used as a template whenever a new user database is created. So modifications made to the model database, such as database size, collation, recovery model, and other database options, are applied to any databases created afterward. Then we have MSDB, which is used by SQL Server agent for scheduling alerts and jobs. So MSDB also holds backup history. So using the MSDB tables, it's possible to determine when each database and file group was last backed up. Then we have tempdb, which is basically a workspace for holding temporary objects or intermediate result sets. One interesting thing about tempdb is that it is recreated every time the SQL Server service is started, and any objects that we've created in tempdb will be gone once the server restarts. So now we'll head on to the pop quiz. So you have this first question: which of these is an edition of SQL Server? The answer is obviously all of these. So Enterprise Edition, Standard Edition, and Web Edition, all of these are different editions of SQL Server. So next question: which of these is not a SQL Server system database? So guys, what do you think? What would be the answer? Well, it's slave database. So master database, model database, and tempdb are system databases, but there is no such system database with the name slave database. So one of the most important tasks of a database administrator is to back up and restore the databases to ensure that there is no data loss. And for this purpose, the SQL Server backup and restore component provides an essential safeguard for protecting critical data stored in our SQL Server databases. So to minimize the risk of catastrophic data loss, we need to back up our databases to preserve modifications to our data on a regular basis. And this is where a well-planned backup and restore strategy helps in protecting our databases against data loss caused by a variety of failures. Now it's time to restore and backup the AdventureWorks database. So I will right click on this databases folder over here, and since I want to restore the AdventureWorks database, I will select this option, restore database, and I will set the source to be device, and I will add a device. So that would basically be the file which I have to add. So I will go to the D drive. So inside D drive, I have this AdventureWorks folder, and this is my database over here, AdventureWorks 2014. I'll click on OK. Again, I'll select this and I'll click on OK. So I have successfully added this AdventureWorks 2014 database. Now I'll click on OK, and I'll just wait for the database to be restored. Right, so we get this message that database AdventureWorks 2014 has been restored successfully. Now, if I open this databases folder, I will refresh this, and we see that we have this AdventureWorks 2014 database over here. Now my next task would be to make a backup of this database. So for that purpose, I will right click on this and then select tasks, and I have this option of backup. I'll select this. Now I will remove all of the previous backup models which I had created. So I will select this. I'll click on remove. Now I will click add and add a new backup. Let me name that to be new backup. I'll click on OK. Now again, if I want the TSQL code for this, all I have to do is select this script, and this would be the TSQL code to get a full backup of this AdventureWorks database. So now I'll select OK. Again, let me wait till the backup is completed. So we get this message that the backup of database AdventureWorks 2014 has been completed successfully, right? So first we went ahead and restored this AdventureWorks 2014 database, and after that I made a full backup of this database. Now let's look at recovery models. So a recovery model is basically a database property that controls how transactions are logged, whether the transaction log requires backing up, and what kinds of restore operations are available. And all of the backup, restore, and recovery operations are based on one of these three available recovery models, which are simple, full, and bulk logged recovery models. So let's start with simple recovery model. Well, as the name suggests, it is the simplest among the available models. So when we choose the simple recovery model, SQL Server maintains only a minimum amount of information in the transaction log. And while using the simple recovery model, we may restore full or differential backups only. So it's not possible to restore such a database to a given point in time, and we may only restore it to the time when a full or differential backup occurred. Therefore, we will automatically lose any data modifications made between the time of the most recent full or differential backup and the time of the failure. So the simple recovery model requires very less administration, and it is easier to manage in the full or bulk log models. But there would be higher data loss if a data file is damaged. So next we have full recovery model. So with the full recovery model, all the transactions are fully recorded in the transaction log file. And this allows us to design a disaster recovery plan that includes a combination of full and differential database backups in conjunction with transaction log backups. And in addition to preserving data modifications stored in the transaction log, the full recovery model also allows us to restore a database to a specific point in time, and hence no work is lost due to a damaged file. Next we have bulk log model. The bulk log recovery model is a special purpose model that works in a similar manner to the full recovery model. The only difference is in the way it handles bulk data modification operations. So the bulk log model records these operations in the transaction log using a technique known as minimal logging. So this saves significantly on processing time but prevents us from using the point in time restore option. So now let's change these recovery models in SSMS. So this would be the command to set the recovery model to be simple. So set recovery simple with no wait, go. Let me just execute it. So see that commands have been completed successfully. Now if I want to change this recovery model from simple to full, all I have to do is write full over here. Now I'll click on execute. So this time we have changed the recovery model from simple to full. Now again, if I want to change this recovery model from full to bulk logged, all I have to do is type in bulk underscore logged over here. I'll click on execute. Right, so this time the recovery model which we're using is bulk logged. Now let's see how can we plan a backup strategy. So after we have selected a recovery model that meets our business requirements for a specific database, you'd have to plan and implement a corresponding backup strategy. So these are some of the questions which we'd have to keep in mind while planning a backup strategy. How many hours a day do applications have to access the database? And how frequently are changes and updates likely to occur? And are these changes likely to occur in only a small part of the database or in a large part of the database? And these are the different types of backup models which we can use. So we have full backups, differential backups, file and file group backups, partial backups, copy-only backups, mirror backups, and transaction log backups. So a full backup, as the name implies, backs up everything. It is the foundation of any kind of backup. So this is a complete copy which stores all the objects of the database. That is tables, procedures, functions, views, indexes, so basically everything. So the full backup will be able to easily restore a database in exactly the same form as it was at the time of the backup. Then we have differential backup. So you can consider a differential database backup to be the superset of the last full backup, and it contains all changes that have been made since the last full backup. So if there are very few transactions that have happened recently, a differential backup might be small in size. But if you made a large number of transactions, the differential backup could be very large in size. Then we have file and file group backup. So whenever the database size and performance requirements make a full database backup impractical, we can create a file backup instead. So a file backup contains all the data in one or more files which are known as file groups. Then we have partial backup. So partial backups allow us to backup only a subset of the data files. So these partial backups will make a backup copy of the primary file group and all read-write file groups. And by default, they will omit any file groups designated as read-only. This means that partial backups are only relevant for databases that contain read-only file groups. Otherwise, a partial backup will capture exactly the same data and objects as an equivalent full database backup. So next, we have copy-only backup. So copy-only backup is a SQL Server backup that is independent of the sequence of conventional SQL Server backups. Usually, taking a backup changes the database and affects how later backups are restored. However, occasionally it is useful to take a backup for a special purpose without affecting the overall backup and restore procedures for the database. And this is exactly where a copy-only backup can be used. Then we have mirror backup. So mirror backups are actually identical copies of the same backup, and these identical copies are stored on multiple locations. So this increases the protection level by having additional copies of the backup set. And in case one of the copies gets lost or is corrupted, we can use the mirrored copy to perform a restore. So finally, we have the transaction log backup. So transaction log backup allows us to backup the active part of the transaction log. So after we issue a full or differential backup, the transaction log backup will have only those transactions that were created after those other backups had completed. So now let's implement backup models in SSMS. So now again I will select this AdventureWorks database, right click on it. I will select tasks, and since I want to backup, I'll click on backup. So this time I want a differential backup. So I'll select differential, and all I have to do is click on OK. And before that, if I also want the TSQL code for this, all I have to do is click on script, and this is the TSQL code to get the differential backup of this database. I will click on OK. So you see that the backup of the database has been completed successfully. Now similarly, if I want to get a transaction log backup, I'll right click this, tasks, backup, and this time instead of choosing full, I'll select transaction log. And again, if I want the TSQL code, I'll click on script. So I'll just click on OK over here. So this time we have a transaction log backup of the AdventureWorks 2014 database. So now let's understand what is point in time recovery. So point in time recovery allows us to restore a database into a state it was in at any point of time. This type of recovery is applicable only to databases that run under the full or bulk log recovery model. So now let's implement point in time recovery in SSMS. So I have this AdventureWorks 2014 database over here. I'll right click this, select tasks, I'll click on restore, database, and I have this timeline option over here. So I'll select timeline, and I will set a specific date and time. So I want to recover this database from 2 hours back. So I'll set this to be 18, and I will click on OK. Right? So this is how we can do point in time recovery. So again, if I want the TSQL code for this, all I have to do is click on script. But for now, I'll click on OK. So we've successfully got the point in time recovery of this database for 2 hours back. Now we'll see how to import and export data in SSMS. So I have this happy database over here, and I want to import a flat file into this database. So for that, I'll right click this. I have the option of tasks, and over here I have to select import data. I have to set the data source. So the data source would be a flat file source. Now let me browse that flat file. So I have this new file over here. I'll open this. Now all I have to do is keep clicking on next. So this is the data which is present in this flat file. Click on next, and then I'd have to set the destination. So I want to store this into my database. So the database would be SQL Server native client. Now this will be stored in this happy database. I'll click on next, and I'd have to click on finish over here. So we see that we have successfully imported this flat file into our database. And now let me refresh this. Let me have a look at the tables over here. So we have imported this new file into this database. Now Let me go to this database first, which would be happy over here. So select star from new file. I'll execute, right? So we have successfully imported the dataset. Now what I'll do is add a new row to this file and export this into a new file. So insert into new file. It will be values, and then let's say the name is Anne and her age is 3. I'll execute this. Now let me look at the modified data. So that will be select star from new file. So we have successfully added this new record. Now I would want to export this data. So this time again I will right click this database and I will select tasks. Over here I have the option of exporting data. Now the source would be SQL Server native client. Now this time the database is again happy. I'll click on next. I'd have to choose a destination. So the destination would be a flat file. I'd have to choose a file name over here. So I want to store this into new file too. And I'll click on next, next. So over here I'd have to choose the table which I want to export. So I want to export this new file. I'll click on next. Now next again, and I'll click on finish. So this time we have successfully exported this data from SSMS. So we have this pop quiz over here. So the first question is, which of these is a type of recovery model? So guys, what do you think? Well, all of these. So simple, full and bulk logged, all of these are types of recovery models. The next question, which of these is not a type of backup model? So we have full backup, differential backup and transaction log backup, but there is no backup by the name integral backup. So dynamic management views and dynamic management functions are system views and system functions that return metadata of the system state. On querying the related system objects, database administrators can understand the internals of SQL Server. So these dynamic management views allow us to monitor the performance of SQL Server instance and diagnose issues with it. Now let's look at some of the properties of dynamic management views. So dynamic management views are composed of both views and table valued functions. Some of them apply to the entire server and are stored in the master database. Others are specific to each individual database. And all of these DMVs start with the prefix DM underscore. Now let's look at some categories of DMVs. So DMVs can be divided into many different categories, and in this session we'll be looking at 3 of those. So we'll be looking at database related DMVs, SQL Server OS related DMVs and execution related DMVs. So let's start with database related DMVs. First we have DM underscore DB underscore file underscore space usage, which returns the space usage information for each file in the database. Now we will use this DMV to get the total number of free pages and total free space in megabytes available in all files in tempdb. So let me just run this command over here. I will click on execute. So the total number of free pages available in tempdb are 3592 and the total free space is 28 MB. Next we have dm underscore db underscore log space usage, which returns space usage information for the transaction log. And we will use this DMV to get the total free log space in megabytes available in tempdb. Now again I will run this command in SSMS. I'll click on execute. So see that the total free log space is 5.74 MB. So this is the total free log space in tempdb. Next we have db underscore partition stats, which returns page and row count information for every partition in the current database. And this time we will get the counts for all partitions of all indexes and heaps in the AdventureWorks 2014 database. Let me click on execute. So these are all of the partition stats for all of the indexes and heaps in the AdventureWorks 2014 database. So here we have different statistics such as index ID, partition number, the data page count and so on. And over here we have the reserved page count, the used page count, the row count. Right, so these are all of the partition stats which we can get from this DMV. Next we'll head on to SQL Server OS related DMVs. So first we have the DM underscore OS buffer descriptors, which returns information about all the data pages that are currently in the SQL Server buffer pool. So with this command over here, we'll get the cached page count for each database. Again, I'll run this command in SSMS. I'll click on execute. So these are the different databases which I have in SQL Server, and this is the cached page count. So in MasterDB, I see that there are 137 cached pages. In MSDB, there are 9. In Sparta, there are 6. And in AdventureWorks, there are 304. Next, we have dm underscore OS threads, which returns a list of all SQL Server operating system threads that are running under the SQL Server process. So this query over here is used to find workers along with time used for execution that are running threads which are actually not started by SQL Server. So this is all of the information about the threads which are not yet started by SQL Server. So we have different columns. We have the OS thread ID, the creation time over here, the kernel time, user mode time, and over here at the back end of it, we've got the address associated with each of these threads over here. Now it's time for the third category of DMVs, which is execution related. So first we have DM underscore exec connections, which returns information about the connections established to this instance of SQL Server and the details of each connection. And this command over here is used to gather information about a query's own connection. So for this query, we see that the session ID is 51 and we have other columns as well. So we have the host name over here. This is the host name. We have the program name over here. We have the login name and we have the original login name, the connection time and the login time. So next we have dm underscore exec sessions, which shows information about all active user connections and internal tasks. And this command over here, it finds the users that are connected to the server and returns the number of sessions for each such user. So we see that there are two users currently. One is anti-service Igneous, another is SA. And for the first user, the session count is 1. And for the second user, the session count is 50. So those were some of the dynamic management views. Now we will work with Activity Monitor. So SQL Server Activity Monitor is a feature in SQL Server Management Studio that displays information about the SQL Server processes and their effect on SQL Server performance. So the Activity Monitor consists of these expandable panes. So we have overview, we have processes, resource weights, data file IO, recent expensive queries, and active expensive queries. Now let's go ahead and start Activity Monitor in SSMS. So over here, I would have to right click on this and then select Activity Monitor. So we have opened up Activity Monitor. So this overview pane over here, it contains the graphs for the most important SQL Server instance information. So this %processor time, it tells us the percentage of time the processor spent to execute threads that are not idle. And then we have waiting tasks. So this over here gives us the number of tasks that are waiting for processor, IO or memory to be released so that tasks can be processed. Then we have database IO. So this gives us the data transfer rate in megabyte per second. And it could be either from memory to disk, disk to memory or disk to disk. And finally we have batch requests per second, which gives us the number of SQL Server batches received by the instance in a second. Now let's look at the processes pane. So this processes pane shows us the information about the currently running processes on the SQL Server databases and who are running those processes. So we have information for session ID, we have user process, we have login name and so on, right? So we see that these are the users over here and these are the databases which the users are currently working on. You see that the user SA has worked on TempDB, MasterDB and this AdventureWorks DB. After that, we have the resource weights pane, and this provides information with respect to a thread which is waiting for a key resource such as memory, CPU or network. So these are all of the threads which are waiting for something. And then we have the next pane, which is data file IO. So this pane shows information about the database files on the SQL Server instance. So for each database, all the database files are listed. So we have all of the different databases over here, TempDB, master, model, and so on. And these are different files which are part of this database. And then following on, we have the recent expensive queries pane. So this pane shows all the expensive queries in the last 30 seconds, which use up a lot of resources, whether it is memory, disk, or network. And finally, we have the active expensive queries, which shows all the currently active expensive queries running. Now we will work with the performance monitor. Now sometimes there might be issues which occur outside of SQL Server that may cause performance problems in SQL Server. So this is where we can use performance monitor. So performance monitor is a monitoring tool which is shipped with Windows, and it helps in tracking various performance counters and monitors overall system and application performance. And these counter values are shown in real-time graphs which can be saved in log files and used for analysis. Now let's work with performance monitor in SSMS. So to open performance monitor, I'd have to click on tools and then select SQL Server Profiler. I will just give the connection name and the password over here. I will connect. Now again, inside the SQL Server Profiler, I have this Tools tab. So I'll select this and then select Performance Monitor. Over here, I will select Performance Monitor, and we see that there is a graph which tells me about performance of the system. Now if I want to add some counters, I would have to click on this plus symbol over here, and I can add all of the performance counters. So let's say I want performance counters related to memory. So let me go to the memory section over here, and inside memory, maybe I want to add available megabytes. I will add this. I will add committed bytes, free and zero pageless bytes. So this is memory. Again, in logical disk, maybe I want the cache bytes. I would also want the commit limit. Now similarly, under physical disk, I would want the disk read time and the idle time over here. Now all I have to do is click on OK. Now if I want to get a report of this, we see this change graph type, and I will click on report. So this is the report which I have. So we see that available megabytes, this is the available megabytes, cache bytes, committed limit, committed bytes, and the free and zero pageless bytes over here. And we have the percent disk read time under physical disk, percent idle time under physical disk, and we also have the processor time over here. Now let's see how can we trace SQL Server activity using SQL Server Profiler. So whenever we are working with really long and complex SQL queries, we have to make sure that all of those tasks are performed accurately. This is where tracing all these tasks becomes important. So SQL Server provides a tool called as SQL Server Profiler for exactly this purpose. So Profiler is a tool for tracing, recreating, and troubleshooting problems in MS SQL Server. And it lets developers and database administrators to create and handle traces and replay and analyze these trace results. Now let's go ahead and work with SQL Server Profiler in SSMS. So we are back to SSMS. Now I'd have to click on Tools and then select SQL Server Profiler. Again, I will give in the password and then establish the connection. Let me click on Connect. Now I'd have to give a new name to this trace. So I will name this as New Trace, and then maybe I will also save this to a file. So let me give in the destination. So I'll save this in my C drive. I'll click on Save over here. Now I can also set the trace time. So let me schedule it. So I want this SQL Server Profiler to run for at least 1 hour, and again over here event selection. So this is where I can set all of those events which I want to be traced. So I'll click on this Show All Events, and let me add some events over here. So I want to trace the cursor prepare, cursor unprepare option, and let me go to the objects tab over here, and I want to know whenever an object is altered, created, or deleted. Similarly, let me go to this performance tab, and I want to know about auto stats. And now all I have to do is click on run. So we see that the trace has started, and we get all of the information over here. So we have the detailed information of whatever is happening. So you have the event class, text data, application name, NT username, login name, and so on. And we also have the reads, writes, and the duration for the reads and writes over here. So this is how we can work with SQL Server Profiler. So now let's head on to the pop quiz. So you have this first question. The activity monitor in SQL Server graphically displays information about what? Well, it displays information about all of these. It gives us information about user activity, blocked processes, and also logs. So the next question is, which database related DMV would you use to get the total number of free pages in tempdb? So what do you think is the answer? The answer to this is db underscore file space usage. So this is the DMV which we'll use to get the total number of free pages in tempdb. So why do we need data integrity? Well, data integrity is used to maintain accuracy and consistency of data in a table. So whatever data we have with us, we need to make sure that it is correct, error-free, and useful. And data integrity can be grouped into these categories. So we have entity integrity, referential integrity, domain integrity, and user-defined data integrity. So entity integrity ensures that each row in a table is a uniquely identifiable entity, and we can apply entity integrity to the table by specifying a primary key, unique key, and not null. Then we have referential integrity, which ensures the relationship between two tables is proper, and we can apply this using a foreign key constraint. And then we have domain integrity, which ensures the data values in a database follow defined rules for values, range, and format. And we can enforce these rules using check and default constraints. And finally, we have user-defined data integrity, which can be enforced through triggers. So now that we know about data integrity, let's learn about indexes in SQL Server. So indexes are special lookup tables that the database search engine can use to speed up data retrieval. Simply put, an index is a pointer to data in a table. So these indexes in a database are very similar to indexes at the end of the books whose purpose is to find a topic quickly. Now again that we know what exactly is an index, let's look at the types of indexes. So in SQL Server, indexes can be grouped into clustered and non-clustered. So a clustered index defines the order in which data is physically stored in a table. And since table data can be sorted in only one way, therefore there can be only one clustered index per table. So when SQL Server, the primary key constraint automatically creates a clustered index on that particular column. But when it comes to non-clustered index, it doesn't sort the physical data inside the table. In fact, a non-clustered index is stored at one place and table data is stored in another place. And this is actually similar to a textbook where the book content is located in one place and the index is located in another. And this allows for more than one non-clustered index per table. And we'll be implementing indexes on this new table which comprises of these columns: object name, color name, and ID. Right, so we have this new table over here. Now if I have to create an index on top of this, we have this index folder inside this table. So I would have to right click on this, select on new index. And if I want to create a clustered index, I will select this option, clustered index, and then give a name to this clustered index. So I will name this as clustered index 101, and I will go ahead and add this clustered index on top of the ID column of this table. I'll click on OK. Now again, if I want the TSQL code for it, all I have to do is click on script. So this is the TSQL code to create a clustered index with the name clustered index 101, and it is built on top of the ID column. So now again, I will go to this dialog box and click on OK. So you see that we have successfully created a clustered index with the name clustered index 101, which is on top of the ID column. Now similarly, if I want to create a non-clustered index, I will right click on this folder, select new index, and this time I will choose non-clustered index. And again, I will give a name to this. So this will be non-clustered index 101. I will go ahead and add a column on top of which this non-clustered index is supposed to be. So I'll choose the color name column. I'll click on OK. Again, if I need the code for this, I'll click on script. So this is the code to create a non-clustered index with the name non-clustered index 101, and this is on top of the color name column. So again, I will finally click on OK. And we have also successfully created the non-clustered index with the name non-clustered index 101. Now let's talk about one of the problem which is associated with indexing, and that is known as fragmentation. So index fragmentation happens when the indexes are scattered all over the database. Well, whenever SQL Server performs IO operation, it initially reads the data from the disk, which is known as physical read. So it pulls everything into the SQL Server buffer. So there is a logical order in this buffer, and whenever the query runs again, instead of doing physical read, SQL Server would look into the buffer, and if it can't find the requisite data in the buffer, that is when it will do physical read from the disk. Now there might be a case where the logical order of the indexes is not equal to the physical order of the indexes, and this is called as index fragmentation. Now why does it happen? Well, whenever we insert or update data, the indexes become fragmented, and as indexes become fragmented, ordered data retrieval becomes less efficient and reduces database performance. So let's actually take this example. So initially we have two data pages for a table with a clustered index. Now a new row with the primary key 5 needs to be inserted, and since it is a clustered index, new row is inserted in order. And because the target page is full over here, the new row does not fit, and SQL Server splits the page roughly into two halves and insert the data into this new page. Now what happens is the logical order of the index does not match with the physical order, and this is when we say that the index has become fragmented. Now to deal with fragmentation, we have two solutions. We can either rebuild the index or reorganize the index. So rebuilding is the process of changing the whole B tree. That is, all the existing indexes are dropped and new indexes are recreated. While reorganizing index is the process of cleaning, organizing and defragmenting the leaf level of the B tree. Now we'll go ahead and implement these concepts in SSMS. So I will take this clustered index and I want to rebuild this clustered index. So if I want to do that, I will right click on this and I have this option to rebuild. I'll click on this. Now all I have to do is click on OK. And again, if I need the TSQL code for this, all I have to do is click on script. And this is the TSQL code to rebuild this clustered index 101. So I will go ahead, click on OK, and I have successfully rebuilt this clustered index. Now I want to reorganize this non-clustered index. So this time I will right click on this, select reorganize, and again select this and click on OK. So this time I have successfully reorganized this non-clustered index. Now let's see how can we get the fragmentation stats of indexes. So we can use this dynamic management function sys.dm_db_index_physical stats to get the fragmentation stats. And we'll be applying this on top of this person.address table from the AdventureWorks 2014 database. So I'll just paste the code over here, and I want these index stats for this table over here, person.address. I'll click on execute, and these are the fragmentation stats for this table. Now we'll head on to the pop quiz. So we have this question over here. How many types of indexes are there in SQL? So guys, what do you think? Well, the answer is 2. We have clustered index and the non-clustered index.
So guys, this brings us to the end of the session, and do stay tuned to Intellipaat's YouTube channel for more such informative videos.